Nyan? I turned off my audio by mistake. Hi!
Kiri.
Wait, why am I so loud? Also, hi! It's just me or am I loud? I might be loud. Am I loud? I think I'm alright. Hi! I'm back! Hi, thank you for the pats. Wait, who patted me? What's going on? Has everything just broken suddenly? I think everything's just broken. Nice, we lost connection to the redeems after... How long was that? Did we reach 1 minute before it broke? I think it's already broken. Nice, amazing. Let's restart the stream. Be there in a bit.
Dot.
Nyan. Hi! How is everyone? Let's see if that actually works now. Oh my god. I accidentally enabled the throwing of the bauble. Whoops. Yeah, that's not gonna work. That's gonna crash my thing. Hold on. Alright, I gotta fix that. 1 sec. I know what's happening now. 1 sec. /main doesn't even mute. Sorry, that ball... You know, I'm gonna delete that. I'm deleting it. Right, it's gone. It's actually deleted. It's not just disabled. It can never be turned back on. You can never, ever throw baubles at me again. Ever! 1 sec. You shouldn't actually have broken it. I have something disabled by mistake. On the Unity side. Yeah, indeed! Alright, hold on a sec. Is it gonna work now? As OBS? Wait, I just muted myself instead of starting the music. Holy crap, I think... How many people's... How much money did I waste with people?
Cheese.
Okay.
Kasaraki.
I'm really sorry for wasting cheese. I'm really sorry.
Cheese.
Oi, cheese.
But I'm gonna be honest. Okay, I deserve that. I'm gonna be honest. With how much cheese I normally get on my face.
Cheese. Formaggio.
That wasn't... That's not so bad. Oh my god!
Cheese.
I only just noticed. Look at all these little floaty particles that come off the names and stuff. Okay, good.
Kasaraki.
Cheese.
Brand new... Here I am! Hi! I was about to say, I guess you won't be able to hear this brand new bottle of Nyan juice opening then. I'm gonna do it while the retro redeem is on. Here we go. Brand new Nyan juice is being opened right now. I'll do it off screen.
Cheese it.
Post.
I'm back! Hi!
Cheese.
You can't see anything! Where am I? Don't look. You can't see it, there are only 4 bars. Okay. Hello, how's your day going? I'm a spooky insect. Hi, where are my hands? Like, wait, I gotta get one close to my face, haven't I? Stop! But hello, hi, I'm really sorry for wasting people's channel points. It's horrible, I wish I could redeem it. I mean, refund, sorry. But I cannot for those ones. However, I did see the hydration from my sensor. Thank you. And the posture check, which I'm doing right now. That's the sound that insect monster makes. Welcome! I'm sorry for missing everything. Hold on, I'm just having a look through the redeems. No!
Cheese.
Well, actually, yes, meow, but no to the cheese. Hold on. I'm back! Hi! The stream can begin now! Hello! Welcome! Next stream we should all activate everything at once. Isn't that literally the beginning of every stream? Like, seriously? Also, welcome, Cabbage and Lulu. Cabbage says, literally saw the notification the moment I went live. The moment I went to the following page. Nice, good timing. PCB design? Yes, Belgian Wolf, although it's going to be super simple, pretty much no active components, basically just a breakout board. Or not even a breakout board, but a joining together board of 2 breakout boards. Because it would require so much wires otherwise. Interested in circuitry now? I wonder what happened. I wonder how that happened. I have been for a long time. Never streamed it though. But now I actually have a thing that I want to make. I guess I could even make photos of it. Well, I have taken photos of the things that I'm going to be sending you. That I'm going to be showing on stream, like in a moment. Hi Siri, thank you for the pats. Who was it who patted me earlier as well? Right before the redeems died. Spitfire. Thank you for the pats. Wait, it might have been Cabbage actually 5 minutes ago. Both of you did it though, so thank you both. And thank you Chaos as well. No!
Cheese.
Not for the cheese. But yeah, these electronic parts I have are from a long time ago. I just never had a use for them. But back when I actually had expendable income, I I bought them thinking I might use them at some point. Never did.
Shot.
Thank you for the pats. And something happened. Yeah, I was helping Belgian Wolf with something, and I thought, huh. It was like with some circuit stuff. Well, like an Arduino sketch on my Discord server, and yeah, I suddenly thought, huh, I have some displays of my own. I never used them. Harvey! Hi! Hi! You missed the chaos, but hi, welcome. Don't worry, I'm sure there's going to be more chaos. My streaming setup died like 3 times and I've only just begun. It was because I forgot to disable a redeem. Someone kept using it and it was breaking. Anyway, hi Harvey! How'd it go? How was your Just Chatting, also known as dev stream? It's every dev stream. How was it? I was there for the beginning for a long part, and then I vanished, and then I came back, and then I vanished. Hi, how's the harp? Should be able to do a shout out again. Virtual Harvey. I need to make sure I actually spell this username correctly. It is just literally virtual. Oh my god! What the that was so loud! What the? Hi, holy hell. Jesus! Also, look at this cutie. Sorry, the clown nose always gets me. One sec. Shitting while pretending to do game dev. That's no. That is game dev. That is deving on Twitch. That is literally how it is. I was having this conversation with, I don't know, I think it was Irend recently. I've had it with my head. I've had it with Doohoo recently as well. This is just how it is. Feels bad when I do it though, but it feels reassuring when other people struggle to get things done as well. But yeah, hope you had fun. Thank you very much for the raid. I'm a weird cat, and that's it. Also, this thing behind me is the Unity. Rest in peace, Unity. Streaming setup of mine. Can I really keep on doing the Unity rest in peace Unity thing anymore since they've gone back on their word? I mean, you know, everyone who cared left their team, right? So I'm sure they're going to do this again in the future. We'll just gradually, you know, like the frog in the pot, gradually make it worse and worse and hope that we don't notice over time, right? But welcome, this. Oh, wait. Wait, is that French? I don't know how that'd be pronounced, so... du silence? Welcome. Hi. Stop! Have you sent the Tsundere lines yet? Wait. wait. What were the Tsundere lines I was supposed to say? I remember I was supposed to say something. I don't remember what it... Kirumi! Thank you! And commiserations or congratulations to Harvey. I don't remember which lines I was meant to say. And hi Coffee as well. Welcome. It's in French. Nice. At least I noticed that. I don't know if I'm actually pronouncing it correctly though. Probably not. We need Kat here. She'll be able to tell us. Code streams are just chatting streams indeed. Exactly, Enlin. You get it as well. Harvey. Let me try that again. Harvey promises she only looked at your tail respectfully. My tail? Look, it's just a tail. That's all it is. That's all it is. It do be tailing. Oh my god, I better not do that. No, stop looking closer. Oh my god, I'm making it worse. Hi! There it is. It doesn't move. I mean, it does move. It used to be rock hard in a non-lead way. Now at least it has dynamic bones. You pronounce it correctly. Okay, nice. Oh god. I started to do the line and then Liquid Cake rudely interrupted with an extremely generous subscription. Thank you very much, Liquid Cake. You just started the scam train as well. Good job. Wait, it actually is a train. Kinami gifted to Harvey, and now Liquid's gifted to Kinami. Now someone's got to gift to Liquid, right? I'm joking. You don't. Liquid's already got one anyway, so joke's on you. Nobody can gift. Also, let me just try to say it. Wait. This is gonna get clipped, isn't it? Shit. I'm gonna say it anyway. It's like I'm doing this for you or anything. Wait, no, I gotta do it with its in face as well. It's not like I'm doing this for you or anything. There you are. You didn't ask for the fart noises on the end, but I did them anyway. Kimmy already had one. Wait, what? You can... Wait, it's possible to gift to people who already had them? Also, there you go. Does that count, Harvey? Yeah, I'm sorry. The stream's just getting started. I didn't even finish saying hi to everybody, so I'll continue saying hi. Welcome, CPT. Welcome, Cardi. Hi. Tinderline is... He's right behind me, isn't he? Or something. Wait, what? It's not a horror line. I don't have any horror music queued up. There's a horrorful? There's a scary looking redeem that you can do, but I don't actually have any music on hand. Why am I being stretched? What is this? You're welcome, Harvey. So in Harvey's, for those who don't cheese. Oh, Harvey, when are we gonna get a cheese from you? I showed you my tsundere, please respond. I showed you my tsundere sound, now I deserve a cheese sound. I'm joking. It'd be cool to have one from you though. Bye, Brit! But yeah, for those who don't know Harvey, she is a very cute,
Cheese.
Nah, she's not a cheese. She's not. Cute, devilish little, thank you for the follow, Brit. Dev. Who also plays games, but she's also trying to make stuff in Unity, and she's also learns like a million different languages.
My singular red eye is looking at you. Yeah, look at this bloom. Look at it go. Wait a minute. I want to look at the sky. Hold on.
Cheese.
Hold on. Wait, how do I do it? There it is. Sheesh! Yeah, hi Cinto. Test works. And hi Julian as well. Hello Julian. Sorry, I won't do that again. And hi Frost, thank you for the pats.
It's Twitchbot.
I don't know. It seems to be working. Thank you very much, Cinto. Thank you for the sub. With Darth Vader voice. Twitch is always bogus. But this redeem came through.
This sub. Okay, I'm back. I promise I'm back. And yes, welcome Holly Hill and Spitfire. And Enlin, of course. Oh god, my hand's stuck in the air. I think it's a Raiden run. She wanted to stay in chat, but mentioned needing to go to bed, headache. Oh no, Harvey! Please have a nice rest. I'm sorry, I hope it gets better. If you're still here. Have a nice rest. Thank you for the stream. I didn't get to say thank you for the stream. So there you go, thank you for the stream. The code took 4 hours to complete. Oh, yours, Belgian Wolf, yeah. You managed though, right, in the end? Right? Hold on a sec. Also, I just realized I missed a redeem from Kinami, which is... Pat. There you go. To be patted. There you go. Better late than never, right? What else did I miss during that chaos? Which wasn't that chaotic. don't think I missed anything. Ah,
Cheese.
I didn't miss being cheese, so I noticed that. Why is my streaming setup running at like no frames a second? Why does this happen nowadays? This bugs me a lot. This used to run smoothly, and now it just goes slow. What's changed? It's running super smoothly on like for real, but it's being captured really slowly. I don't understand why. If I were to switch to a display capture, would that be smoother? Oh, let me try a thing. Is that smoother? Or is this smoother? I'm switching between them over and over. I'm not noticing a difference. Somehow it's become smooth again, but whatever. Sloda, welcome. Mech Banana, welcome. Chaos, welcome. Cabbage, I think that's everyone. I'm really sorry if I missed someone, but hello. Okay, yeah. What are we doing today? Let's have a look. Cheese leak, memory leak. Nah, don't worry, they delete themselves. They delete themselves after they've been falling for like, I can't remember, maybe 2 seconds? Whew. 1955. Wait, what is that? Did I just read out a launch code or something?
Jeez!
My cheese. I wasn't expecting you to stream today at all. Yeah, well, I didn't stream. I should have, oh, thank you though. Really cool seeing you stream on the weekend. Thank you, Spitfire. It is, yeah, because I didn't stream, I only streamed once last week, because it's very busy IRL stuff and it's going to be more busy next week. I'm really sorry. But yeah, alert, cheese, icy cabbage. There's always a warning of cheese. Yeah, temperatures have dropped a little bit. 82% hot, not dying yet. Okay, right. So what am I going to be doing today? I'm going to be designing a little circuit board for, which might be physically big, but super simple. Basically, hang on a second. Let me just test something, 1 sec. Okay, it works. I can tell if the face tracking is working with my mic, because when I make the sound, you see my teeth like that. Otherwise it doesn't work. My mouth didn't seem to be moving a lot for a moment, and I thought, wait, is it just relying on the camera again? So yeah, this circuit board is going to be to mount a bunch of little LED displays to, like little 14 segment displays. They're like 7-segment displays, but they've got like extra like angled segments and an extra vertical segment down the middle, and the horizontal one in the middle splits in two. Basically so it can display letters like M and W that you wouldn't normally be able to display on a 7-segment. I have a bunch of those. Thing is, the display is already on a tiny little circuit board. That's just how it comes from the manufacturer. Yeah, and I have a bunch of those. I think I actually bought them a long time ago with the... Oh, nice, the hype train's over. Nice! Goodbye, hype train! Oh, sorry, scam train. I meant scam train. Did I say hype train at the beginning? I meant to say scam train. Bye-bye. Choo-choo. Yeah, so, basically I was planning to use them at some time. I never did. Or you could say that time is now. Right? So, to drive them, they have obviously... Well, you know what? Let me just fly over to the goddamn scene. Wait, I just realized I don't have a... When I go to my main screen, there's like a logo is meant to appear above there, above the chat. But, I don't have one for electronic stuff because I've never done that on stream before, so I guess I'll just turn the logo off in advance so you don't see it. Is it I2C? No, the display is... It's just a display. It's got a common negative side and then the... wait, what is it? Common... negative side, I think it was, and then a load of positives. common ground, yeah. So I'm gonna just fly on over to a photo. You're not using circuit design software with a logo then. Actually I will be. But yeah, I haven't made a logo for it, so I haven't like made a picture for it, so maybe next time. Right now I'm being a bad, unprepared cat. Hold on. You know what I did prepare? Photos! Sorry, immersion break for just a moment. But would you like to have a look? Because I'm gonna show you whether you would or wouldn't. You ready? Hold on. Is this capturing the correct monitor? One sec. Yeah, it looks like it's gonna work. Ta-da! They look like this. These are really small. That's why you can see little bits of dust close up. It's an unfortunate thing about like small things when you go into like macro mode. The tiniest bits of dust look so dramatic. I swear it doesn't look that dirty. Really, these are these are small specks. So yeah, it's just one common ground and then one of these, you know, pins for each segment. So there are 14. So we've got 1, 2. Well, probably going to be 15, right? With the dot, because the 7th segment is actually 8 if you count the dot. Let's just count them. 1, 2. Wait, let's go top down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes. Including the dot. The dot looks a bit different, doesn't it? It looks dark. I wonder if there's actually an LED behind there or not. Making a time machine? Could do, but I could just use 7 segment displays for that. I wanted to actually display more than just numbers. I wanted to just have a little display. Actually, how many of these do I have? I can't remember. It looks like... By the way, this is one board. So one board has a pair of these on it. Why would 7, 8, 9... Wait. Wait, that's not how the... Oh, I see. That is actually how the joke goes. Shit! You're right! BCC is a separate for each segment. The ground is common. Yeah. Wait. Okay, what I can actually do is fly on over to this, which is the datasheet for it. There you go, 0.4 inches high. That's why it looks so small. That's why the dust looks so big. What is that actually in metric? 0.4 times 25.4. Let's call it 10 millimeters. Let's call it 1 centimeter. There you go, 1 centimeter. Nice. 1. Anyway, thank you for the pats, cabbage. So yeah, there you go. There you are. So yeah, positive will go into each of these at the bottom, and then there's one common negative on the outside, on the other side. 7, 8, 9, 10, and became aluminum. Wait, what is 9, 10? Wait, what is 9, 10? What is this? Is this a chemistry joke? I'm not good at chemistry, I'm sorry. Yeah, that's how it looks basically. So essentially, if you wanted to show like a plus sign in the middle there, you'd want to turn on segments H, M, P, and K, which are 31, 3, 1, and 28. Then you got to look at which of these pins are actually numbered that way. So it starts at 1 down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Snakes around 11, 12, 13, 14, 15, 16. Then you go up 17, 18, 19, 21, 2, 23, 4, 5, 6, 7, 8, 9, 31, 2. So I can't be bothered to work that out right now. Also, thank God, but I do not have to drive these all manually. Those middle bits are also secret pins. Oh yeah, these ones. Yeah. There wasn't enough space basically to put them on the you know, on the outside. So there are these extra holes right there. So what I'm wanting to do is make like a circuit board, just like a long one that you can just put these on top of. I'll probably put some, solder some pins, like some, you know, like header pins onto a board to like stick up and poke through these holes so that I can solder them. At least for these ones. I think for these outer ones I can get very lazy. Because this whole thing sits flat, there's like nothing on the back of the board, it sits flat, it's designed to be a surface mount. Because of that, I don't think I need to solder pins to the board to contact these outer ones. I can probably just make a little pad on the circuit board, and the solder will just like bloop the whole edge of this, like these edges, down onto the pad on the board. So that would save a hell of a lot of time when I'm putting them together. Imagine having to like you'd probably have to put each of these pins in individually as well, because they're not the standard spacing apart. They're 1.9 millimeters apart, which is weird. Anyway, are the outer pins copper on the side or just the top? They're on the top and the side and the bottom. It goes all the way around. I should have taken some more photos, I guess. I should have taken a photo of these out of the little this piece of plastic reel that they're on. But yeah, they're designed to sit flush. I think it actually says surface mount, right? No, it doesn't actually. Oh, there, surface mount display right at the very top. I was looking, wait, where's surface mount? Oh, it's the huge black bold text at the top. Yeah, so they're designed to sit down. They're probably designed for you to actually put solder paste on the board. I've never used solder paste though. So I reckon I can just use pads, like just a region of copper on the board, because that's gonna, like, you know, when you melt the solder onto it, it's gonna be like, it wants to stick and flow onto that stuff. Internet ads taught me to ignore big lettering, I think. Yeah, right? Right? When you're looking for the enormous download here button, then you gotta find the real download link. We need a reflow oven for it though. Yeah, screw that. Wait, would I actually? What if I just like were to make a little, wait, hold on. Alright, it's already time for Microsoft Paint. Here we go. Real stream time. If I made a circuit board like this, and we had like a little pad of solder, like that, like this is like a, what do you call it? Paste, little pad of the paste here. And then on top of it, I put like some board, right? Oh wait, why is this suddenly so thin? Like this. And it's got like copper around there, like that. Couldn't, or maybe if it's like, even if it's properly underneath, even if this was properly underneath, like this. If there's copper on the side, couldn't I just like touch the soldering iron to the copper and it would transfer all the heat through into the paste? I actually don't know. I've literally never done that before, and I know that's not how you minted it. But I don't have a reflow oven, so... There is a name for this, banner blindness. People just ignore banners. Huh, interesting. That is interesting, actually. I always wondered if a regular oven would work. It take a long time to come up to temperature though, right? Actually, I wonder if there's like a diagram that shows, on some things there are. Oh, there you are. This is like how the manufacturer wants you to heat it in order to flow the solder underneath it. They have this like, isn't it crazy? There's like a strict temperature profile that they want you to follow. They want you to rise up to this temperature at 4 degrees Celsius per second maximum. Then throughout this section, they wanted to take 1 to 2 minutes to reach this temperature. And then again, they want you to heat it up, stay at the top for 10 seconds. Good job timing that in a regular oven, and then let it cool down gradually again. I reckon you'd probably destroy some of the plastic if you tried to do it in a regular oven. I think they also, wasn't it this one where it says, yeah, number of reflow process shall be 2 times or less. So you better get it right on your second attempt at the latest. Oh hey, they actually mentioned the pads there. Wow, that's useful. Ah, so these are 2.6 millimeters apart, apparently. Except for these two. Well, I'm not going to make these pads like this. I'll make them just like little rings, like little holes that I can poke a pin through. Oh, that could be fiddly actually. I'd have to solder it. No, it should be possible. This might actually be slightly more fiddly than I thought. Wait, no it won't. No it won't. It'll be okay. What I need to do is... hold on. This is the other paint. I took a screenshot of this because I wanted to show you. Twitch is disagreeing with itself. Look. There's a counter here. Wait, I need something light. 24 seconds until the ad ends. 11 seconds until the ad ends. 13 seconds until the ad ends. Twitch can't agree with itself when an ad is going to end. Anyway. Okay, so what I'd have to do, what I plan on doing is like eventual consistency. Yeah, right? Eventually the ads will end. I think it was actually the lowest counter. When the lowest counter ran out, it got rid of all of the other counters, which is kind of interesting. Hi, Albando! Hi! I just poked the things with a hot stick. Whoa, wait, do you do soldering as well? That's cool. You could potentially just add some through holes and drop some solder down the middle pins too. Maybe. I feel like it's a bit risky. What I'm planning on doing is... Okay, so... On a circuit board... Actually, I could probably show this on the design software because it has a 3D visualization. Yeah, you know what? Let me do that right now. Hold on. It's actually been a long time since I've used the software, like a really long time. Let me just double check something before I do this. Hold on. Am I about to dox myself? Let's see. I thought I checked everything beforehand, but maybe I didn't. Wait, there's one more thing I have to test. One sec. Schematics. I think it's alright. This is the problem with using actual commercial software that you've registered and paid for. I think it's alright. I think there's no way to get it to appear unless you go to the registration window. I like a mini streams, just ready to chat. Well, no worries. Welcome. Hi. Feel free to like. Okay. Okie dokie. Alright. Eventual consistency is an actual thing. Tom Scott has a video talking about it. He does. Alright. Thank you for the posture check and hydration. Like we were just staring at a blank Microsoft Paint screen right now. That's a cute peeking emote as well. What is that? Luminin God? Cute. Thanks for that duration. And also the posture check. They do very obvious. Zappy-zaps. Anything that requires precision I shy away from. Why? The canvas is a metamorph for my brain. Metamorph? Metaphor for my brain. Metamorph for my frame brain. Alright. While soldering, I got a server connected to a Raspberry Pi that endlessly hit a button on my Switch controller to automate crafting in Animal Crossing. Nice! Oh my god, using a Raspberry Pi for that is so overkill, but that almost makes it more beautiful. I remember seeing someone do that with a Tamagotchi ages ago, or was it like one of those, the Pokemon ones, where it just would rotate like this, over and over. Is there a translation? What, for my hub? No, you gotta learn my language. I'm sorry, Sabi.
Cheese.
Whoa, 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 whoa!
Formaggio.
Uh-oh, it's the Omni Onslaught!
You know.
Wait, I'm gonna escape! Ah!
See.
No, 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 no. Oh, it's fun already. Never mind, it's finished. Ah, thank you for the pats. I was gonna try and run away from it. It's just common British. It's not even.
Cheese it.
Alright, so, what I was thinking of doing is basically, we have a board here. Wait, why am I so far zoomed in? We have a board. Actually, it's probably better than I am zoomed in, right? We have a board. It'll have a hole in it. Inside this hole, I will put like a header pin. So it's essentially just a piece of metal like this. And there's a piece of plastic near the bottom. Like that. And I'll just, if I just go to transparent selection, I will put that in the hole like that. So then the underneath is gonna have, if this is a flip side now. So the underneath is gonna like have the pin sticking through a bit. I'll solder this like that to the underneath of this final circuit board. And then on top of this, I should be able to slide on the display. So here we have the display, and it has a hole in it as well. It's actually got a bunch, but I'll just do this, and it's gonna go boop, like that. The pin is gonna be coming through like that. Much 3D, and then I solder it there. That's my plan. So this little pin is gonna be soldered twice. Once on the underneath to the board that I make, and once on the top to the this. Yeah, to this. That feels like a thing that I can do. It's going to be tedious to do this with multiple individual pins, but yeah. Because when you buy these header pins, it comes like this. They come like they come on like a long strip like this, and there's just like a piece of plastic that goes along joining the bottoms like that. And when you want to use one, you can just like, with your fingers, you can just go like, snap them off like this, and now you've got these. But because these, oh yeah, and they're spaced like, what is it? 1 1/4. What is it? What's the spacing again? 2.54 millimeters apart, I think. Unfortunately, these are not 2.54 millimeters apart. They are. Scrolling intensifiers 2.6. Although, you know what? That's only 0.06. I wonder if I could squeeze them in a bit. I wonder. It's very close. Probably not. I might be able to get away with just 2. 3 might be pushing it. Because the error in the spacings. Yeah, the bottom ones are really, really small. But I'm not going to use pins for those ones. I'm just going to be like having them sit on, Oh no. Oh no. Uh-oh. I can't do it this way. Because if I have this board sitting on top, it's going to be resting on this piece of plastic. So when you look at it from the side, you've got my board, the little display board on top. There's going to be like plastic separating them, so you can't flow the solder down the sides of these edge pieces like that. Ah, that's going to be a problem. You can put the plastic to the bottom. Yeah, but then how am I going to solder it? I guess I could solder it with a tiny blob on the top face here. I have it on top, not the bottom. Wow. You solder from the top, then place the board, then solder again. That would certainly make less of this separating gap here. But again, I'd have to solder well, otherwise I might lift it up a bit too much. But, you know, it probably won't be too far. I just gotta get good and it'll be alright. Alright, we'll do that. We will do that. Wait a sec. Hang on a sec. There's a much easier solution. There's a much easier solution. I can do it this way. So let me just draw it one more time. So we've got my board. Hold on. My board. Then we got a little bit of plastic surrounding this pin that goes up through it like that, right? Well, I solder it at the bottom around here, and once that's done, it's secured in place. Like, with pliers, I can just grip this plastic part and just slide it right off the pin. It's not hard to slide it off once this pin's secured in position. I can just like pull it right off, and then we'll just have the pin. Alright, it's decided. There are multiple ways to do this, so I think that's one that I'd like to try. I still think you can just drop solder down the holes. I probably can. The only thing I'm worried about with that is that it might accidentally pull out between the boards somehow, and I don't know if it would or not, but I wouldn't be able to see it until it came to testing it. That's the problem. I'd be like constantly thinking, oh no, have I just ruined everything? Oh, I'd be worrying that 6 times actually, you know? What if it goes down and it just goes bloop and joins these two together? The pop, oh yeah. Hang on a second, let me do it properly. Let me just actually, let me just pop off this plastic, yeah, ready? There you go, that's what it'll actually sound like, except hopefully I won't actually break the pin. Alright, so that's the first stage. This is a part that I'm gonna have to make. So when you're designing for a circuit board, there are 2 kind of stages. Well, 3 actually with this software. Hi Finny! Welcome! The age-old wisdom of just get good and do it right. Yeah, right? That's the solution to everything. I don't know why people just didn't think about it, right? Depressed, just don't be sad. Homeless, just buy a house. These are simple problems, right? Right? Hi, Finny. Yeah, I don't know if I actually would lick her cake, but yeah, I'd worry. Okay, so there are 3 stages I'm going to need to do. Firstly, I'm going to need to recreate this part in an editor with like accurate measurements, and that is what's going to determine what will appear on the final circuit board. That's going to determine that the holes will be at exactly these positions, and there'll be little bits of copper at exactly these positions, and there could also be some like screen printed stuff. So basically, you know, drawing on the board, just to guide me, you know, to say, hey, these holes are for a display. Not, I mean, it's going to be pretty obvious. Actually, it might not be that obvious when you put a whole lot of these side by side, which is what I want to do. It might not be so obvious where one begins and where one ends, so I would probably like to have the outlines of these drawn on the board as well. So that's the first step. Yuki, solving the world's problems in simple ways. I love this long nuke so much. I'm sorry, Fox. The second step is making the schematic. This is basically telling the design software how everything should be connected up together. So basically, yes, there are going to be holes in the board, and yes, they're going to be connected to this display by me, but I actually want these little connections on the board to go somewhere. I want them to be routed to something. Spoiler. I also have a little chip like an LED display driver, that is what they're going to be going to. I'll show you that in a sec. And the third step is to actually lay them out on the board, like actually make the real design and route everything together. That is such a therapeutic part, because at that point the circuit software knows, but it's DipTrace, by the way, I should mention the name of it. DipTrace knows, the same goes for other software, I'm sure. At that point it knows the physical so-called footprint of these parts, and it knows how things should be connected. So it will guide you and say, okay, you need to join this pin to this pin. And you can like route that however you can. It also has an auto-routing thing. Is not... Genuinely, you can get much better results yourself. Also, routing is very therapeutic to me. I don't know if we'll get to it today, but yeah, maybe we will. What's the use for this circuit board? It's going to be to join a bunch of these displays. Hold on. A bunch of these displays to... I think it'll need to be 2 LED driver boards, which look like this. I actually already have them as breakout boards, so that's a little bit annoying. Well, I mean, it's kind of nice because it's got additional support circuitry here. It means I can basically just, and it even comes with these headers as well, which is really nice. It means that I can just design a row of pins on the board, right? That I'm going to drop that board onto. In the same way as I was going to put pins to drop the displays onto, I can just put a row of pins here and drop this driver board onto it. Not have to worry about this smoothing capacitor, these extra resistors, and some other stuff that I'm not even sure this is for. Oh, it's a diode, isn't it? But yeah, so this is a driver board. Let me just show you it. This is a little bit confusing because not only can it drive 8 up to 16 segment displays, and these are technically 15 segments if you count the decimal point. So that's fine, that's fine. It'll be able to drive 8 of these. Nice, nice, nice. Well, 4 of these boards, right? Because one of them contains 2 digits. But anyway, not only can it do that, the reason... What the hell, someone just screaming outside. Anyway, that threw me off. I don't know if you heard that. What's going on? Anyway, secondly, the reason it gets more complicated is because it can also use, like, repurpose some of these pins in between it scanning out, like, pulsing all of the LED segments, because it has to pulse them. In between doing that, it can, like, temporarily switch some of these to, like, inputs and read, like, key presses from them. The idea is that you can use this both as an LED driver and like a little interface for buttons, like on a keypad or something, which I'm not going to do. I don't want to do that. I don't want to make it any more complicated, but that makes it a little bit more confusing when you're reading documentation and looking at example diagrams. It's like, wait a minute, I got to make like a matrix of keys and it scans through them and like, No, we don't have to do any of that, thankfully. I guess you're sending this off to be printed rather than etching yourself. Yes, I will be doing that. I don't really have the space to be doing it myself. I don't have the chemicals to be doing it myself, and even if I did, I would need like a sink and some stuff, I guess. That it doesn't matter if I accidentally burn off the nice finish from it. I don't think the people I'm living with would appreciate me doing that, so... Yeah. So I'll be making a board on here, and then I will send that off to a company. I've used... Wait, what is happening? When I hot glued my eye tracker to the bottom of my screen, because the sticky pads broke, I didn't do a very good job. It's not very straight. Anyway, I have used like some PCB manufacturing companies before. I actually used JLC PCB. And it went fine. So I'll probably use them again. Anyway, hashtag absolutely not sponsored by anybody. Okay, that said, it's been a long time since I've used DipTrace, which is this circuit design software. Alright. 1 second. Let me just... Hold on. Okay. I think we're ready to show it. I know you're seeing a black screen right now. But are you ready? Hold on. Whoosh! Here we are. So this is the pattern editor, and this is where you, congrats on sponsorship. I do not have one. Hopefully you can buy lots of cheese. I'm not flipping sponsored! Not yet. I have to prove myself first, and possibly making such a simple breakout board. It's not even a breakout board, it's literally joining 2 breakout boards together. Simply...
Cheese.
One does not simply cheese. Making such a simple board, I don't think is going to get me a sponsorship anytime soon. But yeah, you can see that the reason I wanted to make a board like this is because imagine having to wire up all of these displays. Well, all of these displays. That's a lot of wire. That is a lot of wire. That's like, what is it? 30... How many is it? 32? Yeah, 32 wires per display. That is so much cutting and stripping of wire and like, oh my god. So I think it might actually take longer to design boards for it, but it's such a nicer use of my time and more fun, you know? I'd rather do it this way. It seems like a fun thing. I've wanted to... Why? I mean... Sure. Hi Freb, how you doing? Cheese, X, cheese, chess, oh. Oh, don't worry, I can't play chess either. You missed the slap stand sponsored by Cathedral City. Cathedral? What is Cathedral City? Oh wait, let me guess, it's a cheese company. I know you have trouble with straight things, blah blah blah, another lesbian joke and so on, yes. Wait, did I say something about straight? I can't even remember. I think you can make a little guide thing out of some styrofoam packaging to sort of auto-align the pins. Sounds interesting. So yeah, the board is just going to be to... Wait, then, you know, let me just quickly check. Where are they? There we go. I know you can't see these right now, but I'm just counting the number of these displays that I have. So we've got 1, 2, 3, 4, 5, 6. Hold on a second. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 of these as a whole. So 16 of these characters can be shown. And hold on. And this software is called DipTrace. This is like one of several different parts of it. So we've got, this is the pattern editor. This is where you design like the footprint of stuff. You name the pins. This one is named 8. It doesn't actually have a name, it's just got a number and stuff. This is like where you design the physical layout of the different components and stuff. Right now I'm looking at just a bunch of standard ones that it comes with. There's a lot. There's a lot. And then after this comes the schematic part. Hold on, it's loading, it's appearing on the wrong monitor as well. This here, which is where you would like add components like this. Boop, boop. Wait, let me zoom in. This and wire them together and stuff. I thought you did Scamdema for a second, and then you can connect to other things. Blah 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 blah. You know, you make a schematic and stuff. And then the final section is the PCB layout. Why I'm using 16-char LCD for aesthetics? Yeah, purely. This is purely for aesthetics. I just got these because I thought they're nostalgic to me. They remind me of like the front display of like VCRs or something, like video video recorders, video cassette recorders. So I thought, yeah, why not? They're green as well. Which also just feels like a more retro color to me. I'll have to like take photos if I get it working. And then, by the way, this will be being controlled from an Arduino in the end. So basically the idea is, and then maybe like from a computer. So the computer will send text that it wants to display to the Arduino. The Arduino will convert that into, okay, we need these segments on these displays to be on. And it'll convert that into like a command that needs to be sent to the actual LED driver, which I've been talking about a whole bunch, but I haven't shown you yet, so maybe I should load up the datasheet. One sec. Okay, this is the one. Yeah, it comes in a bunch of different ones. There's this small one, slightly bigger, and then the big one. This is the big one. This is what I have. This one can drive 14. It's like, wait, how many are these working? Yeah, it looks like all of these can drive up to 8 displays, because you've got common 0, 1, 2, 3, 4, 5, 6, 7. But this small one can only drive up to 8 segments, or 9 segments actually, by the look of it. And this one can drive up to 11, 12 segments. And this one can drive up to 16 segments. So this is the one I have. So you send commands to that, and then that will do the work of actually driving all of the segments. Hi, Okami! Welcome, welcome! Take a look at media share on Discord for a video I made years ago on Animal Crossing crafting automation with a servo. That sounds interesting! I remember when blue LEDs were invented and everyone used them for a while. That still happens! That still happens too much! My computer has a blue power LED, my USB hub has a blue LED. Anyway, yeah. By the way, the actual displays used on the VCRs that I remember weren't LCDs. Well, weren't LEDs. They were, what are they called? VFDs? Vacuum fluorescent displays? Which were, it was like this kind of cyan color, which is really nice, but it wasn't green. It wasn't an LED. Hold on a second. I'm having a look at this video that Spitfire linked. One second. This looks interesting. Can I show it on stream, Spitfire? Yeah, so how this chip works is, you may notice, you need 32 pins to drive one display. And yet somehow, this chip, with only this many pins? Wait, hold on a second. Yeah, somehow this... Wait, no, sorry, you need 32 pins to drive 2 displays, right? These are 2 separate ones. But they're basically completely standalone. Each one of these displays has its own common. So how can this thing drive 8 16-segment displays with only 28 pins? Well, it basically just uses the first common pin and all of these rows for a moment to show something on the first display. Then it uses the second common pin for the second display, and all of these same row pins to drive the second display, just flash it for like a fraction of a second, and it does that in a row for like up to 7 displays. So it like scans across all of the displays really, really quickly. Just sending tiny pulses. Wow, thank you for the hydration! And yeah, then you can just tie together all of these so-called row pins, which are like the segment pins of all displays together, but then only the display that has its common side connected will actually do anything, right? Because there's no path through all the other displays unless you connect the common pin. So yeah, that's the idea. And then finally, yeah, so it goes computer to Arduino to driver to display. All right, thank you for the hydration. Oops. Excuse me. My god. You trying to drown me, Sabi? Yeah, no need to shift register. The typical thing of showing things so fast, you're seeing an optical illusion of multiple numbers, while in reality, only one number is shown at a time. Yeah, the thing that cameras hate when they have like a really high refresh rate. Cameras hate this one weird trick. Go for it. Okay, I'll show her. Oh my god, I really am flipping, choking. Yeah, I'm alright, thank you. Welcome. Hope you're doing alright. We just wanted to have a quick look at a video of Spitfires. Hold on, what's the best way to show this? Let's load in this tab. A solution to bulk crafting in Animal Crossing. Hold on a second, is my stream gonna die now? Did I just die for a second? I don't know. This is a thing that Spitfire made. Wait a minute, 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 wait a minute. Hold on, hold on, hold on, hold on, hold on, hold on. It's literally just pressing. It's just pressing the same button over and over. Oh my god, it's the same thing! All the button defaults to the same... to the correct action. Oh my god. That poor servo though. I can't believe a Raspberry Pi has been renegated to the position of output one pulse width, output another pulse width, output one pulse width, output another pulse width. Meanwhile, it's running like Linux at billions of cycles per second. Oh, how modern technology is abused. Anyway, that's cool and funny and pretty cute. The tiny arm. I know, it's just like... Wait. Did I miss a thing? I did, hold on. There you go. A nyan for the Omni. Okay, so, yeah, when we start looking deep into the datasheet, it gets a bit more complicated. Well, this is not even the complicated part yet. Where it gets to the actual complicated part is when you start... Yeah, here's the thing, this is why it's more complicated, right? 16x8 LED controller driver. Okay, with key scan. That's where it gets complicated. Anyway, there's a lot of stuff, and the way you communicate with this is through I2C or I2C, but it's literally written I2C most places, so I just call it I2C. Fight me! Anyway, so... yeah, you write to addresses to control things, like, for example, the brightness of the display. Hold on a second, sorry. I2C. Nice. Yeah, this goes on for a while. Whee! Anyway, hopefully we can make it work. I don't need the start page anymore. Go away. Heading over to fight right now. No! I'm sorry. Okay, yeah, right. So the first thing I want to do is make a pattern for this. What did I just do? I just did a thing, and I removed half the buttons on this toolbar. What the, huh? What did I just remove? It's like the navigation thing or something. Oh, screw it. Let me just reload this program. I've literally never seen that in my life happen. Hold on. I can never get them back now. Yeah, I guess I can't, huh? I guess I can't. They're gone. Oh, wait, I see. They're floating on my other monitor. What in the name of God? Get over there. One by one. Okay. So what I want to do first is make this footprint on the pattern editor. Here we are. Windows reinstall. You use solid cheese board. No! Don't do that. Tool bond! Oh my god, that's quite good actually. Kind of hilarious how few pins that chip uses for control versus output. Yeah. Yeah, the input is... it's literally 2, right? Well, or 1. Like, no, 2, right? Serial clock and serial data. Hold on, where's the other one gone? So I2C is a protocol where you have 2 pins, and with just 2 pins and ground, which you just kind of have for free, right? So with 2 pins, asterisk plus ground, you can communicate with, in both directions, with like a microcontroller. It's uses some fancy trickery to let one pin be the clock, which I think is always controlled by the microcontroller, and the other pin can switch between input or output. It's yeah, fancy. There we are, SDA and SCL. So it's serial data and serial clock. Then you power the LEDs with one of these. I think it was VDD, and VSS was power to this. And yeah, then all these other pins, all of these, those ones and these ones are outputs. Well, actually, this is the small one. This is the big one that we're using. The outputs, asterisk, unless you're using them for key scan stuff, and then yeah, it's a bit complicated. Some of them are also used as inputs during the startup procedure. Yeah, it's a bit confusing, but essentially these ones, A0, A1, and A2, it looks at the state of these pins on startup, and these determine its address, which is basically when you're sending messages to it, it'll respond if you're sending messages to the right address. I2C works. It's like an addressed protocol, kinda. You send commands to an address. You can have multiple devices all sharing the same data line. Just like you can have multiple LED displays all sharing the same rows. So you like configure these pins to set an address. A bus, yeah, that's the word. So essentially it looks at the state of these pins on startup, which is why you need a bit of a weird circuit with resistors and a diode and stuff, so that when it's reading these pins, it's not interfering with the LED display. Anyway, that's something I don't have to worry about too much, because thankfully the little board that I got, rather than just a chip, has that stuff on it already. That's these 3 pins here. A0, wait, flip it around. Hold on. These A0, A1, and L2, A2 here are these little things. You can bridge them together and then it joins to resistor, blah, 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 TLDR. Anyway, it gone. Oh, not again. Not again. Help. There we are. Sorry. Didn't realize. Sorry. I'm back. Let me just go through it again. Here. These little things here is A0, A1, and A2. This is what this little breakout board does for you. So you can just bridge these 2 little pads to set the address, basically. I think it's binary. So this would be binary 0. Bridge these 2, it becomes binary 1. Bridge these 2, it becomes binary 2. Binary 3, binary 4, 5, 6, and 7 is all of them, I think. So yeah, then what you're doing when you bridge those is you're like connecting some pins on this chip via a resistor and a diode to somewhere else. We don't need to worry too much about that, but it's just a thing. If I scroll down to the diagram. There you go. It's these. So you've got like the A0, A1, and A2 pins up there. You can optionally bridge them with a blob of solder through these. And if you do, then they become connected via a resistor to one of these pins. It's really weird. It's confusing because it's reusing pins for different things. Anyway, so normally these are common grounds, right? These are common. This. There you go, cabbage. So normally these are like positive. So stuff would come out, go through the LED matrix, and go through to the common. That's why there's a diode here, backwards. So when you're using it in the normal way, the stuff to control the LED display will come out, go through here, but oh, hits this diode, can't go through there, so this part doesn't work when it's controlling the LED displays. It only works when this pin temporarily goes high during startup. Anyway, it's kind of an interesting way of like minimizing the number of pins they need on their chip, but it makes it more confusing for small brain people like myself. Anyway, let's not worry about that for now. Let's just make a pattern. Let's just make a layout for this. Baby. I feel like I should get fingerless gloves with how cold things are feeling all of a sudden. Maybe. I have not been able to find any that are the right size. I've literally tried only one, so I haven't tried that hard. But... Darkness, Dementia, Raven. What? DDR? Did I say DDR? This game you're working on is looking a bit different. There are some super cool LED drivers which drive even more with the same pins by reversing polarity. Well, thankfully for me, this is not one of those. Alright, let's start designing a pattern. So these are all built-in ones. If I go over to user patterns, or user... wait, do I want user patterns or user components? What's user components? Alright, this is where I've made some of my own. Including this. Like a... wait, where is it? Wait. Ah. Where is it? There we are. Oh, this is PCB layout. Whoops. That's why I'm getting confused. Hold on a sec. Pattern editor is what I want. Oh, it's already loaded. It's just in the background. Let's get rid of that. Let's get rid of that. And load this. Here we are. Right. Here we are. Look at this one. Look at this one. This was a fun one that I made. Anyway, let's make one called... what should I call it? Why is there cheese on me? Hi, cat! How's the cat doing? You can connect two of these over them, one each way round. Yeah, I get it. Wait, show hands? My hands are here. Wait, what happened, cat? What happened? Did I say something sus? This is makers and crafting. Yeah. I'm trying to do, like, I'm trying to make electronic circuits and stuff. They didn't have any category for electronic stuff. I'm making a circuit thing. It will be in real life. I'll use, usually make markers and crafting. Streams have hands cam. I was making a little yolk. Why is it so cute when you say yolk? I mean, it's cute when you say most things, but also I'm going to stop raising you live on the stream. I'll say that for a stream. I want to make a new component. So I'm going to add a new pattern to own patterns library. Wait, is it add or insert? I forget. Add, right? Yeah, that'll do. Untitled. Alright, what should we call this? It is this thingy. This is its name. Boop. The manufacturer is Kingbright. Data sheets. I don't really have one for it. These are all fine. Alright, let's do this. A little uke. That's even cuter, what the hell? Okay, so let's try to make one of these then. So in total, it is 19... Wait, hang on a sec, what are these units? All dimensions are in millimeters, brackets, inches. Alright, nice. So 19 millimeters. Got a snap set to... Oh, why are these measured in inches? Wait, was there a way that you could change that? I can't remember. What is a millimeter in inches? God. Mind you, it actually does have the measurements right there in inches, so we could just do it in inches. Oh, let me have a quick look. Was there a way to change this to actually show stuff in millimeters? Where the fuck? I can't even remember where the settings were. It's been so long since I've used this. Oh, wait, units. Millimeters. There we are. Nice. So this is going to be 19 millimeters wide. tall, sorry. And 18.8 wide. It looks like everything is 0.1 millimeters. If you know what I mean, there's never any more accurate than 0.1 millimeters. So I'll just snap to 0.1 millimeters, I guess. Which is really small, actually. Let me just make the 19 thing first. Right, so we want a square. Kind of want it to be centered as well. So if I actually want it to be properly centered, then how is that? That's... What's 19 over 2? 9.5. Didn't say I could do maths. Okay, so 19.5. Wait, what? Alright, so... Does it actually tell you the size? It does. And so 9.5 in that direction. And then... Oh my god. Ta-da! Alright. Wait, it was 19 tall, not wide. It's 18.8 wide. Wait, fine. Hold on. So 18.8. So what's 18.8? You didn't see that. 9.4. 9.4 up. And 9.4 down. I know it's 9.5 right now. Wait, if we can just be snapping to 0.1 anyway, I might as well just do that from the start. If that's millimeters, what's the other number? Inches. It do be inches. So the height is 18.8. So I'll take it one down. One down. And the... Wait, what am I doing? What am I doing? It's 18.8 wide. What am I actually doing? There we are. And the height is 19. There. Height 19. You know why I'm doing it? It's because I'm looking at the top, right? Because I'm trying to look vertically, so I'm looking at the top. And then when I'm looking for left and right, I'm looking at the right. But actually this line is for the length of this line. There we are. 0.559 inches. What is this bastardization of metric and imperial? I know, right? Hi, Fisher Run. It's because it's, I guess, primarily made metrically. Wait, no, this one is 10.16. Mind you, that's just the gap of these, so I don't really care about those. I only really care about the positions of these holes. But yeah, thank you for the follow, Fisher. Welcome, welcome. Outrun, I should probably call you, right? Sorry. Do more conversions of units, please. Share your mathematical knowledge to us. I don't have any! Okay. So that's that. Right, where does the first hole appear? Well, it's centered down the middle. Oh god. Oh god, stop! It's just like when I'm switching between Blender and Unity and trying to remember the different camera controls. For this, you can use middle mouse button to pan. For this, it locks the panning, and then you middle click again, it doesn't stop it. It just keeps panning. Stop! Oh my god. What the hell? I can't stop it. Oh, you actually have to left click? You do, you can convert it from inches to millimeters. Did I? Did I? These are millimeters, right? Yes. Don't scare me like that. Out of the frying pan into the PDF. Wait, wait, what? Okay, so... what's a good way of seeing where the first hole is? Actually, you know what? Let's just see how far apart they are. They are 1.9 millimeters apart. So let's start by making a row of little notches, 1.9 millimeters apart. I mean, I don't have to actually cut out this, but, you know, if I wanted to make it look fancy, I could take notches out of this. I actually forgot how to do that. How do you do that again? Isn't there a way that you can, like, notch out? Board cutout? Wait. No. I forget. Well, who cares? Let's just make it a square. The important thing is where the pads are. I could also put a separating line down the middle. Boop. So this is actually the silk screen layer. So this will actually appear printed on the board, if I'm not mistaken. By way of using a calculator, but it's a calculation you used. Oh, the times 2.54? To go from inches to millimeters? Yeah, I guess so. Actually, you know what? I'm gonna go to more chill music now. Boop. Yeah, let's do that. Okay, so let's actually put the pads on because that's the important stuff. Let's make a row of pads 1.9 millimeters apart, and I don't know what size they're gonna be yet, but yeah. Let's what? Let's test? Let's test? Is that what that wiggling ass means? I see. But welcome, Fart. How are you farting? So I want this on the signal layer? What was it? Oh, top. Just top, right? Top assembly. Oh my god. It's been too long since I used this, I swear to god. It's been way too long since I used this. Mask? Oh, okay, you know, one sec, I've actually forgotten how the hell to do this, so let me just have a quick look at one of the other things that I made. So this is on the... Which layer is this? Top, obviously, but top assembly? I guess? God, it's been too long since I used this. I feel like a complete noob again. I guess top assembly. Top silk is at top assembly. Fine, I'll make it top assembly. By default it is top assembly anyway. Well, that doesn't look the same. Place pad. That's probably why. Mounting hole. I thought you could... Oh my god. I feel so stupid again. I don't remember how to do basic things. Help. Okay, so you can do it like that. Thank you for the pad, Stu, and thank you for the hydration and posture check. I'll do this right now. If I didn't have this little library of things that I've made before, no one would ever believe that I've ever used this software before. Okay, so these need to be 1.9 millimeters. Oh, posture check as well. Oops, almost forgot. Yeah. Okay, there we are. Gremlin has burst out of me, also known as posture has been checked. Okay. So, we want these 1.9 millimeters apart, which means... Well, how wide is a pad? Wait, they said down the bottom what they recommended for the pads. Oh, there, 1.2 millimeters. And 1.9 apart. Sure, I can oblige. They actually recommend, look, they actually recommend that the board here is 19 millimeters, right? They actually recommend that the pads go a little bit under and a little bit out as well. That would be if you're actually doing proper solder paste stuff. I'll do the same. I might as well make it the same. So they recommend that these pads start at the boundary, which they do, and they extend, well, they're 2.5 millimeters high, so I can just change that I cannot change that? I can change that. 2.5 high. Width of 1.2. And then place them 1.9 millimeters apart. Wait, I swear there used to be a way to do... Yeah, wait, here we are, a pad line. Oh, let me just do that first. How does one, Wait, why is this not straight? What? Why is this not straight? I think that's straight. Wait, what the... What the hell's the options for that? Huh? This is certainly a row of pads, but... How did one modify how it places them down again? Place pads, a line of them, yeah... How do you change the settings for that, actually? I don't think I've ever used that option. Ah, placement setup? Is that it? So these should be spaced 1.9 apart, right? Thank you for the pads. Is that the right setting? Yeah, there you go. That looks like they're 1.9 apart. Okay, now I just need to... Well, actually, let's use a ruler to see... From the center of... Well, from the edge of this one to the edge of that one. Wait. What? I've forgotten how to even measure something?
Formaggio.
Why? Apparently I've forgotten how to actually measure something. Oh wait, never mind, it says down in the bottom left. It's not quite the way that I was meant to be doing it. Yes, length 1.9. Okay, they are 1.9 apart. Nice! A row of pads, no, a row of pads. Okay, where do they start? What's the offset from the beginning? Well, I guess the way to tell is that it's centered, so we could just shift them across until they're centered. Wait, I'm gonna have to make a 0.05 gap, aren't I? There we are. And we'll lower them down so they're centered here as well. Are they actually centered there? Can't tell. Is that centered? Looks roughly centered, doesn't it? Looks good. Thanks! Wait, why do they reckon 2.5 high? Can you adjust all of these in one go? Oh, they already are, correct. Right, I forgot that I typed that already. But that means I would need 0.05 to make them properly centered, right? I don't know. Who cares? I think 0.05 millimeters is gonna be fine. And then I'll copy those. Actually, I should probably number them first. Okay, so the top row. Bearing in mind, this is gonna be placed down from above. So we're starting at pin 32 up there. Can I number these in a row like this? I wonder. Pad array numbers. Whoa, this is interesting. Pad array numbers. Type linear matrix, left to right, rows top down. First pad is 32, step -1. Minus, wait, really? Can I not go -1? Well, I guess I could say right to left. And the first pad is 32. Wait. Wait a minute, what? 35? 4, 3, 2? Is that right? 41. 40. Okay, I see what it's done. This is weird, but okay. 23. I should number them correctly. 32. 31. 23. Nice. So they're numbered correctly now. And then we'll just copy all of these to the bottom. Wait, can I just do it in a... Can you paste in place? I guess not. And... No, that actually is centered now. Yeah, that actually is centered. Oof, oh my god, why is this scroll bar so high? I mean, so sensitive. And we number these ones from left to right, starting at 1. So this is now pin 2, I hope. This is pin 9, I hope. Yep. Alright, now I just need these little through-hole bits in the middle.
Formaggio.
Why though? A tooltip came up? A tooltip came up? Oh, when I was doing the measuring? I'm trying to think. What was I... Wait, what was I doing at the time that made you say that? Jesus! Why so angry? Thank you for the pats. Clunk! Hi! Measuring of the ruler. Okay, I was. Nice. How are you clunking? If anybody is interested in, well, I don't know, not necessarily electronics, but the equivalent of electronics of the programming world. So, Emacs? It was Emacs you used, right? Then, yeah, follow Clunk. Also, if you just like someone who's goddamn entertaining and is somehow always on, I don't know how he does it. But yeah. The E in Emacs stands for electronics. Yeah, electronic Macintosh, right? Then yeah, I highly recommend. And he said highly recommend Emacs. I don't. I've never used it actually. But Clunk probably would. Anyway, I highly recommend Clunk is what I was trying to say. My god, if I could get a word out, that'd be great. A sentence. Yeah, Clunk has a setup which is like the whole goddamn VTubing setup is inside Emacs. It's actually integrated into it. He has an ASCII mode display of his avatar. You can change the text that makes up the name. You can change it to emojis. You can change it to Twitch emotes. It could be animating Twitch emotes. Oh my god, hang on a second. I just... Wait. I just... Shit, hold on. I just went like this, and it actually made my headphones cut off onto only the left speaker because the plug of my headphones is so almost dead. I need to re-solder it sometime. So imagine, where is it? Imagine this, but more detailed, colored, and you can change the text that's making it up. Yeah. So and it's not a shader. It's actually being shown, you know, as text. Oh, you didn't see that. It's very cool. Just a fun stream. Oh my god, every time I tap. By the way, I did actually make this be colored at some point, but I decided that I prefer it to be green. What's the end goal of today's hardware project? I wish I could turn off this effect, but I can't. I gotta wait a minute now. Probably only like 20 seconds at this point. Hi Irish! Booba! Hi. Pretty shit stood for 8 megs and constantly swapping. Hold on a second, I almost missed... Wait, I have to do something important. You're gonna get pats now from the Holy Yuxabi. I almost missed this redeem, hold on. Pat. There you go. Pats for the Sabi. As requested, like, how long ago was it now? 2 minutes ago, okay, not too crazy. Bye, Cardi! So this project is to connect up a bunch of these little 14 segment displays, which are technically 15 because there's a decimal point. They come on a board like this. And yeah, I want to make a little circuit board that I can just use to mount a bunch of these displays, 8 of them, so we'll have 16 characters in total. And to mount one of these, which is a controller for it, and like a driver for up to 16 segments. Wait, we'll have to mount 2 of these actually, because one of these can control up to 8 characters. And I'll have 16 characters, so I'll want 2 of these, which I have. Whenever I come across like a really, really cheap but useful looking chip that is being sold like in China, I'll usually just buy a bunch of them because they're like absolute dirt cheap, you know, like so cheap. I don't even remember how cheap they were, like maybe $2 or something. Because you know, in case I might need them for, you know, if I use them and they're useful, then I probably want to use them again. And sometimes it's hard to find them again, so I'll buy a few. So I have a few of these. Not a huge amount, I think. Wait, let's find out. Hold on. 1, 2, 3, 4, 5. I have 5 of them. China is amazing. It is, right? But the what I actually got from China is a breakout board, so it's not actually this. It's this and a few, you know, useful supporting components. So actually what I have is this. So really, I'm gonna have to just make another one of these patterns just with a bunch of holes around the outside. Thankfully, these ones are standardly spaced apart, I think. I think these are... I should measure it. You know, I'll measure it right now. Wait, I gotta get a ruler. Hold on. Hold on. So it comes with these pins. I think they are 2.54 millimeters apart, but one sec, let me just measure. Hold on. I could just wait until I'm actually doing these ones, but one sec. Let's measure. How many pins are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 9 gaps. And the total gap is 22 and a half. So if I do 22 and a half divided by 9. Yes. Oh, the 2.5. They're 2.5. Okay, not 2.54. They're 2.5. Okay, they're 2.5 millimeters apart. The metric version. The one where you think, huh, that's probably close enough. And then you try and put like a row of 10 and the error builds up and... it's not good enough. Put that back and put this back. I bought some SoCs some time ago and never got around to using them. I was pretty wowed when I got a literal reel of computers. Ah, that's so cool! Yeah. That's cool. That must be cool. It is funny how they come on a reel, isn't it? I swear, I'm saying things... I'm saying so many things. So those who don't know, I guess most people wouldn't, it was a bit of a weird in-joke, but Fixit Freb, who was here earlier, has a thing where he likes to do the what was it, cyberpunk meme of like the most innocent things are interpreted lewdly. You know, like when I said come on a reel, it might be like suddenly it cuts to me and the music plays with a screenshot of me and the white text underneath it. He's been doing that for a whole bunch of streamers, and the number of times I've said the word come this stream, I'm probably going to end the stream and find that he's made like 4 goddamn meme videos of me. Anyway. What will the Blinky Boys be used for? I don't really know. This is why these displays have gone unused for years since I bought them. But I thought, just the other night, I was helping Belgian Wolf with like a little Arduino thing, which was like a 7-segment display project. And I thought, damn, I have, like a long time ago, I got a few of these displays and I never used them. This kind of makes me want to use them. So I at least want to make a display out of them. Something that can be used much more easily. Because I was going to just play around with this and I realized, wait a minute, there's 32 goddamn pins per pair of these. I might not even have enough wire to connect them all up. So let me make a board and then afterwards I'll thing what to display. And afterwards I'll probably make a display so I can take a photo and never use it again. But yeah, no, maybe in the future I will. What I'd probably do in the future is try to remake it in Unity for the streaming setup so that you can see it. Like maybe it'll appear down there at the bottom. In real life, maybe it can do the same thing, but you know, you'll not be able to see it. Scope creep, I know. Oh yeah, right, that's what I was doing. I need to know where these middle holes are spaced apart. That'd be some nice shaders. Huh. Yeah, actually it would be kind of similar to a shader that I've already made for the DDR machine. I basically made a shader for letting you turn on and off lights on a DDR machine, where the lights are just actually emissive textures. So basically it just has many how did it work again? I can't remember how I did it exactly. But you can basically specify lots of tiny little maps for emission. They can be like really low resolution, so it's a lot of textures, but it's really low resolution. And then I think there was like a slider that you could change from 0 to 1 to control how much emission there was on that light. I guess I could use it again for these. It's probably not very fast because there are a lot of textures. That's a lot of separate samples, isn't it? A lot of samplers. I don't know, this is going a bit low level. I don't really know what makes a shader go slowly. I imagine that would be something. Okay, let's see where it recommends for the... Here we are. For these inner pads, which are not going to be pads, they're going to be through hole, but let's just have a look. So they are spaced 2.6 apart. Oh my god, stop! Huh? Which is annoying, because the pins are spaced 2.5 apart. But maybe if there are just 3 in a row, they might be close enough. The error of 0.2 millimeters might not be too bad. Because it's only going to be a row of 3 there, and then a row of 3 there, a row of 3 there, and a row of 3 there. Might be able to get away with it. Being a bit naughty. Offload the computer to IRL photons. Oh, did you know that there's do you know that a group has made like essentially optical like neural nets? Like they've been able to kind of 3D print a series of lenses. I think it was like a series of lenses that would like at each layer, so each lens, it would like deflect slightly the light to where it's entering the next layer, and then that layer deflects the light a bit more, and to the end it like at the end the light like shines on like a label that marks the output of the neural network. So you could put like a photo detector there, and it's like the most subtly warped lensing at all. So but on the input you can put like essentially a picture and shine light through it, and like everything warps, and then at the very end it can like point to, this is a digit 6 that's been handwritten. I've detected a 6. And obviously it works at the speed of light. You just shine light. As fast as you can turn on the light and read the result, you've got the result. I don't know why I haven't seen much progress in that. That was like a few years ago that I saw that. That feels amazing. Obviously you can't, you know, you have it once and it's a bespoke thing, right? I imagine you must need incredible accuracy. It's probably not very resilient to like bumps because the tiniest bump is going to completely misalign one lens, and you can't. Yeah, exactly. You need to kind of bake it, right? You can't retrain it. You got to do all training first. convert it. Oh my god, my chair is so creaky, sorry. So yeah, it's not like a thing you can retrain. It's purpose-built. It's still pretty goddamn awesome, right? Optics are super expensive, especially aspherical. Right. Yeah, it's making something that accurate as well. Maybe that's why we haven't seen much of it. It's kind of a shame though, right? Because it almost feels like the ultimate end game of neural networks, right? Like you can't get faster than the speed of light, right? But at the same time, it's limited in application, I guess. And it's weird. It's like we had a glimpse to the ultimate end game. On the topic of electronics, someone also did something like this with... They kind of... Okay, I might be remembering the details wrongly. Also, my hand is not in the air. That's the leap motion, thinking my mic is my hand. But there was also a group that made like a neural net that can... Oh, I gotta remember the details of this correctly. They made it an electronic circuit. It was like a circuit, a network made out of a circuit. How does this work? I'm trying to remember this. It was like... I'm not gonna remember this correctly. But essentially, you had like input neurons, if you like, nodes, and a bunch of variable resistors all the way throughout. So every variable resistor was like a weight in the neural net that you can adjust. And I think they used like actual like digital potentiometers, so not really the analog ones, but the ones that can be controlled through commands. And if I remember rightly, I might be getting this wrong. The details might be wrong, okay? Take this with a grain of salt. But basically, you had some inputs, and then there was some potentiometers like this. You know, these were like the weights, if you like, from each one of these. Yeah, whatever. Blah blah blah. I don't know how stuff was connected, but in the end, you had a bunch of inputs, a bunch of weights, which were potentiometers, all like connected through, you know, like crossing shit, I guess. And then a bunch of outputs. And the really clever thing that they did to train it, the cool thing is that they made the training stage super quick. Essentially, the backpropagation was just physics, just working as physics normally worked. So what they did was they would apply what the input should be, right? Because when you're training a neural net, you show it what the input is and what the output should be. You give it like these pairs of training examples, right? So you put like something in there and you want something out there, right? And the really cool stroke of genius idea they had was, what happens if we provide input and we provide output? We force these to the output that we want. And what you end up with basically is that you'll get a voltage on the this part I can't remember clearly, but essentially some of the current is going to end up flowing backwards and stuff through these. And it's sort of, you're going to get a mixture with the with what's coming in and what's coming out on each of these potentiometers. Now I can't remember how they did it. They like measured the difference between those or something, and then it just adjusted the potentiometer in one like operation so that it would, I can't remember. It was something like that. But the really cool idea, in my opinion, was that the idea that they could do this in electronics, and just by applying like a current on the output as well as the input at the same time, you'd get these conflicting ideas of what this value should be, which is kind of like how it works in like an actual artificial neural network, and that this just worked in electronics as well, like naturally in a way. You know, you didn't need to make special electronics for it. I guess you set voltages on each and measure currents over the pots. It was something like that. I wish I remembered the details, but it was so cool. But I just had to mention it even though I can't remember the details while we're on this topic, especially since I'm doing electronics now. But yeah, I should maybe re-find that article because it was cool. It was another one of these just little proof of concepts. I think it was a tiny neural network. But the fact that it actually worked was really cool. Biological nets don't use backprop. Yeah. I corrected myself when I said real neural network. It was so cool. It was almost on the level of something that I feel like, you know, normal people could make. You know, like, people can't just bend glass lens into the correct shape for the optical version, but, you know, if all you need for the other one is, like, a bunch of potentiometers, essentially, and, well, I guess a load of ADCs to measure the current, but... Anyway, let me get back on topic. 2.6 millimeters apart are these pads. So let me do this again. Placement setup. So we want them 2.5 millimeters apart. I don't care about the vertical separation because it's just going to be a row. And wait, is there not a way to set the precise pad placement? Pad array. Align? I guess this works. Wait, why can I not set the height and width before I place them down? This is weird. Actually, you know what? I might make these pads shorter on the inside. Because if I'm going to have to cut a hole there for the through hole thingy, it's going to be quite close to these pads, isn't it? I'm only going to be flowing solder from the outside, so I don't really need them to travel far onto the inside. I might cut these pads short. Inputting inputs and also forcing the output to match the coming inputs. Forcing the output to match what you want the outputs to be, given those inputs. So for example, if the inputs were pixels in an image, and the outputs were labels for what is being displayed on the image. Trying to remember how to... Thank you for the pad assistant. Trying to remember how to pan. Hi, cat! The cat in a jacket kind of cat, not the K-A-A-T cat. Oh my god, my nose is itchy. Sorry. Am I explaining it well? I couldn't even remember the story, the article, but thanks. I'm noticing this is not... Is this properly symmetrical? I don't think it is. I'm over my head. I'm in over my head on this one. Oh, don't worry. I'm not going to be making anything that complicated. I'm just trying to draw squares where the docs tell me to draw squares at this point. Sorry, my nose is so itchy. Just insert hand inside my head. Oh, actually alignment's not too bad. Alright, let's have a look. So these pads are 2.6 apart. Let's make a row. Bup, bup, bup. Yeah, these are differently spaced. I guess that's 2.6. Yeah. Only want 3 though. Stop. You can go away. You 3 pads, I want you to be more square. What size do they recommend? 1.3 millimeters. Wait, I don't want them to be pads though. I want them to be through hole. 0.9 millimeters round. Wait, hang on. What kind of size is a hole by default? 0.9 sounds tiny, but let me just... I guess they are pretty goddamn small, aren't they? Let me measure. Measuring the holes on this. I don't have like a... What do you call those things where you can measure the width of... Calipers. I don't have calipers. So I'm just using a ruler. It's not best because it only goes down to 1 millimeter, but this hole is... It probably is 0.9. It's fractionally less than 1 millimeter. Wow. I think 0.9 is a decent size. Might have a good personality, you know. That's cute. Yeah. Wow. When you say 1 millimeter, it sounds tiny. But when you look at it compared to like the size of other things on the board, I realize, oh. Yeah, it's kind of wide, huh? Because the whole board is only a few centimeters across, so yeah. I only have school level knowledge on this stuff and I want to know more. Man, I'm so lucky when people can learn programming and electronics in school. I didn't have any of that. I got into electronics from a friend. I got into programming from... I don't know, I guess Game Maker. I think Game Maker was what first got me into programming. Game Maker version 4. Back when it was by Mark Overmars. And not by Yo-Yo Games. Wait, and then it got bought by... Opera or something, right? I just discovered recently. Right, offset from whole, blah 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 blah. Sure. Are these going to be used? Probably are, huh? Wait, ellipse. Wait, hang on a second. What are these names? Ellipse. Obround. What is an obround? Is it like a rounded oblong? Obround. What is that? Obround. Okay, so I guess if I make these like this, yeah. No, don't change everything. Ah, hold on. Let's untick use pattern standard pad properties. Through hole. Round ellipse question mark 1.2 1.2. Oh, hold on. There's a standard. Yeah, that's nice. Standard template. Width and height. Oh, wait, that's a pad though. Hold on, I'll get there eventually. Type. Through hole. Template. Okay, so that's a template for surface. What other templates do we have? Round, round. Oval round. Ellipse round. Square round. Okay, I guess round, round is what I want. Through hole. 0.9, 1.5. That sounds alright. Sure. Obelisk? Obelisk plus round? I do not know that word. Maybe. Okay, where do I want these positioned? And then I'll see if they're too close to these pads for my... too close for comfort. So the gap should be 2.6. I guess I'll double check with the ruler. I'll measure from there to there. Length is 2.5, not 2.6. Oh. Did I type it wrongly? I did! 2.6 is what they should be. Huh! Wow, I'm glad I checked that. Can I adjust the placement after they've been placed? Doesn't look like it. Oh, wait. Just kidding, I can. Wait, this looks way further than 2. Wait, that's spacing from the edges, isn't it? Line by center? Let me just place a new array. Whee! They should be now 2.6 apart. Let's measure that. From corner to corner, 2.6, sure. I guess measuring from the center would be the easiest. Yeah, 2.6. Nice. Okay, the correct distance now. Let's just make them what they should be, which was round, round. Nice. Now I gotta know where to place them. Oh my god. Keep forgetting how much there is. I forgot to use the page up rather than stuff. Okay, so the middle one should be aligned with the top hole. Or the middle hole here should be aligned with this middle hole here. Okay, let's do that then. There we are. And vertically, looking for a measurement of how far down. Okay, it looks like they are spaced apart by 14.2 on the center. What?
Cheese.
Hi, Holy Hell! I am. How are you? I got the art of electronics, but it's more of a reference than an explanation. Egyptian tower thingy. Oh. That reminds me. Nail? Nail? My brain hurts from the screen. What is going on? I don't know how to... I'm trying to make a board, like a little circuit board, that I can put a bunch of these displays onto and control them. I want a row of them. They're going to be 16. Well, 8 of these pairs. That's basically it. It's going to just have a nice way for these to mount on so I can solder them and not use a million pieces of wire because each one of these pairs uses 32. Thank you for the pad, Solkami. 32 connections. And I don't want to... I don't know if I have enough for 32 pieces of wire multiplied by 8. Nor the patience to actually cut and strip them all and solder them. I feel like doing that is just asking for like at least one of them to go wrong, right? There's also going to be this to drive them. So right now, I'm just making in this design software the layout of the, like where all the pads go, so that later I can place this, like stamp it effectively onto a circuit board multiple times. And connect all the dots and do a dot to dot, as Linted would say. Join the dots. Hi, F-Paul. We gerbering? We are. Eventually. But yeah, hi Dunk. Hi Paul. Or F, if I'm... No, D. I've got to shorten you to D, if I'm really shortening everybody to the first syllable. Deej. Wait, that sounds like I'm shortening Degen. Hi Uni! Thank you for the pets! And thank you as well, CB. Alright, so I need 2 rows of these. Oh my god, what am I doing? Oh, I see. I need 2 rows of these. Wait, let me copy and paste these. Position them so the center lines up there. I love all of these little lines that show up to show how things are aligned. Ah, so satisfying. It's like polar opposite of trying to make things in Blender, where it's like, oh, just eyeball it and see. P.S. everything's floating points, so do everything a few times and you lose precision. Hope stream is going well, and hope all of chat is well also. Yeah, stream's going fine. It's very laid back. I should do this more often. It's way more relaxed. I think there's less expectation. It's more like, it's almost closer to art, question mark? Because I'm just positioning things visually, I guess? I don't know. It's like accurate art, but I don't know. It's actually nothing like art at all, is it? Because it's super accurate and I'm needing to follow someone else's instructions. So I wouldn't really call it creative at this point, but I am making a thing. Yeah, I hope you're doing alright. CAD. Yeah, well, it's definitely CAD, yeah. Computer aided design, yeah. Alright, let's align these like that. And now, these need to be, how far apart was it? 14.2 millimeters. There is a way somehow. Yeah, this is it. What's up? There's a way where you can position 14... We'll do it this way. You can position something like this to mark exactly where it is. So 14.2 is 7.1, right? Apart. Why can I not? Oh, there we are. Wait, that's 7, not 7.1. Shit, hold on, I messed up. Add a measurement, 17... Oh, right. Because I haven't actually made it the correct distance yet, right? That's why it's snapping like that. Well, I was only off by 0.1 millimeters. That's not too bad, is it? Alright, we'll put that there. And And then this should be able to snap. Oh wait, I want all of them. Hold on. Ah! All of these. That should be it. That is it. I think. Yeah. Alright. And then I want to do the same on the other side. I'm just going to move these out of the way a bit. Let's take from here down to 7.1. Come on! What? What's happened? I thought I released my mouse button. What's my mouse doing? 7.1. 3, 2, 1, there we are. Sure. Oh my god, wait, why is the text there now? There we are. Alright, so now I should be able to drag that down and they should be able to snap. Actually doesn't snap. It's not very satisfying, is it? I mean, it is centered. Centered there as well. Alright, whatever. That should be it. Those pads are kind of close, huh? And the thing is, they don't need to be close because I'm not going to be soldering underneath the body of this. Okay, computer aided uke. Wait, copy and paste cheese? What? That he right there. Sorry. I find it amusing. And high priest. Wait, did I say high priest? High priest. There you go. There you go. The following pad numbers. Oh yeah, right. I haven't even assigned pad numbers yet. Hold on. Let me assign pad numbers now. What are we doing? We're going 11, 12, 13, 14, 15, 16 from left to right. These pads. Starting at pad 11, right to left. So that's pad 11, pad 13, pad 16. Nice. Thank you for the pads. Not the pads, the pads. And then across 17 to 22. You're kind, gravel. 17 left to right. That is 17, 19, 22. Nice. Now I should be able to save and it shouldn't complain. Boop. Nice. I had pants. No. There's a tiny gap between them. 0.2 millimeters apparently. Also, when I'm placing these onto the board, I'm gonna have to keep in mind tolerances. Which is here. Plus minus 0.25 inches. Millimeters, sorry. 0.25 millimeters. So... probably gonna want to make a gap between them of that. Or double that? I guess double that, right? Something like that. I'm not sure. Because what I really don't want is to not be able to squeeze them to each other, and like maybe I have to like file down the edge of the board to get them to be able to fit side by side correctly. That's not a thing I want to do if I can avoid it. Also, I actually noticed that these have round holes and square pads, so I could actually do the same thing. Oh my god, not like that. How do I move? Stop! There we are. So I could just do the same thing there. All of these and all of these can have square, round. Boop. There we are. That's very close to these pads. It's probably fine. It's probably fine. But if I can avoid it, you know. The round hole goes in the square hole. Exactly. Alright. Make it a bit shorter. What about 2 instead of 2.5? It's like so confusing, but at the same time relaxing. I'm glad it's relaxing. The really fun thing is when you actually like join all the things together. That's super satisfying because it's just like so therapeutic. It like tells you, it will draw like what's called a rat's nest, which is just like a load of lines. Like imagine like a blue line joining here to here, or there to there, and there to there, and they're all like, you know. So it's basically saying, hey, this thing needs to be connected to this thing, for example. And then you're free to just like route lines any way you want. Hold on, let me just load up the PCB layout thing so you can see an array of pans. It's literally like dots to dot, or join the dots. Because it knows where things should be connected to once you've made the schematic. So for example, if I just dropped a few things, hold on, it's not going to know where to connect any of these, but if I just randomly drop some of these, for example, then you can imagine there would be lines between them. And then all you need to do is you're free to just like route things in like neat ways from place to place. It becomes like really satisfying. You can even, if you want, you can even do like really flipping fancy ass arced. Wait, how do you do this again? How do you do this? How do you do this? There's a way that you could have curved corners as well. Oh, like that. Whee! Should you want to make a really arty board? I've actually like drawn silly things in this way before. Oh, hang on, I just made that in a really non-neat way. And I don't think it's actually designed for people being arty. It's more probably to do with like cutting down on... I just realized I'm connecting something to itself, so I deleted it. I think it's more for like cutting down on like radio frequency interference or something. But you can make like... Wee. Boop. That's not neat at all. Anyway, it becomes therapeutic is what I'm trying to say. I probably won't do that. I'll just keep them like this, but I don't know. By the way, there's other fun things you can do as well. If you're trying to, if you're dabbling in the black magic world of RF stuff, radio frequency stuff, and you need a path to be precisely the right length because that makes it work like an antenna or something, I don't know, RF stuff is black magic, then you can use this. Hold on, where is it? Not that one, not phase tune, wait, where is it? Stop. How do you do this again? No, that's not quite it. Where was it? Was it this? No, it wasn't this. Where was it? There's a way somewhere where you can tell it to be like a precise length. Precise width. Where was it? Length matching. It's less that I want to make it match another length, it's that I want it to... Okay, what if I say I want it to be precisely this length? I wish I could remember how you did this. I'm not going to need to do this, but it was fun to just play around with. Oh well. Can't remember where it is. So much stuff. It's not that. Never mind. I can't remember. Oh well. Maybe some other time. But essentially you can say that you want this trace to be a precise length, like, I don't know, 10 centimeters, and then you just like, it will just automatically go like zigzag, zigzag, zigzag to make it sure the length is precisely how long it should be. Wait, I swear I was able to do that relatively easily recently. One second, Factorio Railways? Wait, do they need to be a specific length as well? Or is it just that they are often made that way? Route manual. I feel like it was an easy thing. I wish I could remember how to do it. Show the length? Doesn't actually seem to be telling me the length. Ah well. Another time. Okay, so I think these are positioned where they're meant to be positioned right now. I just want to make these a bit shorter. Length matching feels like it's more like a signaling thing than an RF aerial thing. Like if you're running at 4 gajillion hertz, you don't want something a gajillion just a second longer than something else. Yeah, actually, I think you're right. I think it is more about making things arrive at the same time. But it is, like, again, a thing that only kicks in when you're running at the high frequencies, but yeah. It's less about radiating it out into the world, you're right. Okay, let me just add one more dimension. This thingy. I'm gonna make a measurement coming from this corner up to the top of this. Wait, really? Is it just that? Yeah, okay, it's just 1 millimeter. So maybe I'll knock off, like, I don't know, 0.2 millimeters? I think I'm worrying when I don't need to worry because the gap between them is already that big. Well, small. But I'll just knock off a tiny bit, 1.8, let's say. And budget up to match that. And budge this one down. 2 then, I guess. 1, 2. There we are. So now it's asymmetrical and it's longer on the outside than the inside, but that's how it should be. Alright, I think that's everything. I could have stopped this a while ago, but there we are. I guess our stuff is probably on the most likely times you're in the ludicrous signaling rates. Maybe. I mean, CPUs run at crazy frequencies, right? They might need length matching. Alright, I guess that's that. Let's just make the one other pattern, which is this thingy. HT16K33. Alright, where are we? One more pattern. Wait, do I need another pattern for this? These are 2.5 millimeters apart on the breakout, right? Yeah, I should probably make this a pattern. That's annoying. That means I've actually got to measure this board. I don't have any documentation for this little board. This one. So I have to measure it. Let's take it out of its bag. There it is. Grab the ruler. Oh, it's nice and cold. Okay. Now we measure. Wait, I should make a new thingy first. New pattern. Boop. Let's call it. What is it? HT16K33. HT16K33. Underscore breakout, I guess. Oh, and it's the 28 pin one, I guess. Let's call it 28 pin breakout? Question mark? Manufacturer of the chip, at least, is it Holtec? Yeah. Alright. And we will... This is a nastily long name there, but whatever. Let's do it again. Right, how big do we want this rectangle to be? This should be a lot easier. Mind you, I'm eyeballing some things. Some of these holes are crazily close to the edge of the board as well. Like, really close. Thinner than the width of a hole. Anyway, the length of this is... Hold on, my tracking's probably going to go weird because I need to get really close. Hold on. 1, 2, 3. Yeah, 35 millimeters. So let's just draw a box, which is a website I'm meaning to be using at some point to help with learning drawing. It's called Draw a Box. Right, so 3.5. So in other words, 3.25 on one side and 3.25 on the other side, right? Wait, no, hang on a second, what am I talking about? 3.5 divided by 2, 1.75. You could please. 1.75 to the left. By the way, these don't have to be centered, it's just more satisfying when you're placing it. Wait, why am I so far zoomed out? Wait, was I zoomed out? These are millimeters, right? Wait, what is it snapping to? Huh? Do you see that? It's not doing it anymore. Wait, these are millimeters! Hang on a sec, I'm being silly. It's 0.5 centimeters I should be snapping to, not... Wait, what is it? I'm confused. These are centimeters. These are millimeters. Okay. So I can actually snap to just 1 millimeter, yeah. No, half. Hell, my brain's turning off.
Jeez.
No, it's not gonna help. Also, I've got to be quiet soon. Right, so we want 17.5 to the left. There we are. And I'll also drag it 17.5 to the right to make it 35. Hi, Sticky there. Thank you, Ascento. Right, I think I'm actually gonna have to go into quiet mode. 1 second. Right after I've hydrated, I'll do it. There we are. Thank you for the hydration as well. Alright, I have to adjust a setting. There we are. Sorry, that was a bit louder.
Jeez.
But yeah, now I can be much quieter. And yeah. You're gonna hear my mouse clicking more probably. Some of it. My jeez. Okay, how tall is this? It is... exactly 2 centimeters. So I'll go 10 millimeters up there. And 10 millimeters down there to make 20. Have I been drawing this on the wrong thing the whole time? Yeah, I have. I've been drawing this on top assembly instead of top silk down. There we go. Okay. Now where do we want these holes and how far apart were they? 2.5, right? Let's measure this. Does this look like 2? Hold on. Hmm. 1, 2. No, 14. Okay, hold on a second. You know what? Maybe they are actually 2.54 apart rather than 2.5. I think they actually are 2.54 millimeters apart. In other words, 0.1 inches. Why must you mix units? Okay, and how close are these holes from their end? Let's have a look. Looks like. I would guess it's meant to be the half of this. Time to switch units. Boop. Wait. I do still want this. I just want to use this. Okay, so I guess... Oh god. Oh god. Why? What the heck are we converting? I'm trying to measure the size of this. And the positions of these holes. I don't care about these big ones. No Imperial in professional world. Yeah, unfortunately there are though. The standard spacing of pins is 0.1 inch, 2.54 millimeters. Well, a standard spacing. There's also 2.5, confusing me. It really does look like it's exactly this width though, but maybe I could stretch it to just be like there instead. So then instead of 35 millimeters, it's 35.5 millimeters. You have a bunch of pins there. Do they fit? Well, these are the ones they came with. And yeah, they fit. They fit. But yeah, this came with these pins, this little breakout board. I'm gonna be honest though, it doesn't look like it's 35.5 millimeters, it really looks like it's 35 millimeters. Go look up a pattern for pins and take the measurements from there. I know that pins are 2.54 millimeters apart. I'm just trying to position them correctly. Well, I guess I could center them, huh? I guess I could just center them. Yeah, then I just need to know how far from the edge they are. And the edge, let's say... one... and a tiny bit, so probably 1 point... this. Probably that. I thought they were 2.5, but measuring the holes, I think it's 2.54. I'll recalculate with the pins though. Let's have a look. I don't know. Looks like somewhere between 2.5 and 2.54. I think this will be okay. The actual holes I'm measuring on the board, just what I'm really worried about, because I know that the pins fit in there. And these are easier to measure. Pretty accurately, 33 millimeters from the first to the last hole. And there are 14 holes, which means 13 gaps. So it's 33 divided by 13 gaps, and you come out with that number. So I reckon they're 2.54 about. The level of accuracy I order, well, I mean, yeah, we'll hope. 3 holes are usually not as perfectly accurate as other things. Well. Okay, so I might keep this that size and then position the pads. Where are we? Pad to pad spacing is 2.54. We don't care about Y. Sure. We'll just get 14 of those. Then I'll just position those evenly between them. Wait, that already is evenly between them. No, that already is evenly between them. I mean, like, sorry, it already is centered, sorry, is what I mean. So... yeah. And then, okay, so horizontal position is probably fine. And vertical position there would be, what would that be? If we measure from this corner down to this center, 1.11. Wait, let me put that measurement on the outside, it looks messy. Corner to center. Does that seem about right? It is tiny. Tiny, tiny, tiny. Yeah, that's probably fine. That's probably fine. I'll just go with that. I think that'll be fine. Going to BRB for a few, so going to be looking for it. Yeah, no worries, Uni. Thank you for the look. Thanks for hanging out. Even though this is an incredibly weird, slow, nerdy stream. And since I can, I think I might make these a little bit wider. It's just because I can. I have the space for it, so why not? Yeah, alright, let's copy that and paste. Alright. That should be that. Let's just make sure they're numbered correctly. How does it go? Right, they're not numbered on here. They are given names. So let's have a look at the data sheet. Do you have numbers on here? Yeah, we do. How do these correspond to what's on here? PDDs in the top right, SDA, SCL, A0, A1, A2. Wait, A0, A1, A2? But here is A2, A1, A0? Oof. They reversed those. Wait. Oh, they've numbered it. Wait, are they? Yeah, they've named them wrongly. They're calling it A instead of R. Right, these are the row numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because on this thing they've printed, look, on this thing they've printed here, they've used A all the way down, A0, A1, A2, but also down A6, A8, A9, 10, 11, 12, 13, 14, 15. So these are the rows. Yeah, they just named them wrongly, but that's alright. And then, I just realized at this point I can just be looking on here, and you can be seeing as well. It's an easy way to show this. A11, 12, 13, 14, 15, C7, 6, 5, 4, 3, 2, 1, 0, and ground. VSS. VSS was ground, is it? VSS, negative power supply, ground, yes, okay. Okay. So the layout is identical, nice. So I can number them this way. Top left being 1. Wait. What's the rotation of this? I guess I have to decide on the rotation now, huh? Right, so since the text is the right way around when it's rotated this way, I'll make it this way. Which means VDD in the bottom right is pin 28. So VDD in the bottom right is pin 28. Right to left, 28. Now the one on the left is 41. Wait, what? Wait, I've messed up again, hold on. 15, sorry, 15 left to right is what I meant to do. 15 left to right. 15, 28. And on this side, we'll have 1 to 14. This one is right to left. 1 to 14. Nice. You can always rotate the component in the PCB as needed. Hi, Kelvin! Hi. How are you, Kelwing? Sorry I couldn't stick around for the rest of your, music stream. It was like 4 AM. The first one was alright. The second one was too late. Wait, you said BRB, I've really just been talking to myself. It actually doesn't matter if the A numbers are reversed, these identical drivers on the bus. What? Because here, look. A210 012 is what I was worried about. It doesn't really matter that much anyway, because, you know, I can just change the code of the Arduino to match, but anyway. You can always rotate the component in the PCB editor as needed. Yeah, true. If you're using only these, I just mean you can fix it in software. Yeah, true. There'll be like a thing I need to bridge to set the address of one of these as well. I'll need to put a little blob in there. That's fine. Alright, let's give these some names as well so it's easy to wire up. So we've got ground here. Wait, note? I thought there was a name you could give pins as well. Are you crazy? I was once. Pin terminal? Oh my god. Can you name these, or do these actually need to be numbered? You can name them. Number ground. Right, fine, I'll make these notes. Ground. This is C0, C1, C2, C3. I love the way it remembers which thing has focus. C4, C5, C6, and C7. Then you've got A15, which I'm going to call R, because these are rows. Row 15. Which one's this? Is C7, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 15, 14, 13, 12, 11. And then down in the bottom right we have VDD. Serial data, serial clock. Wait, serial, not serial. Did I do it for this one as well? No. And then R0. I guess I could use a multimeter to make sure that these really are. Should I do that? I probably should. A is usually analog. Yeah. True. Oh. Let me just. I'm gonna use a multimeter. Hopefully this beep won't be too loud for people trying to sleep. We'll find out in a minute, I guess. Okay, I just want to make sure that this one that it calls... Wait. So much stuff open. I want to make sure that the one that it calls A0 is actually A2. Row 0, so this pin. I'll just measure quickly. Okay, I need to move my mic out of the way. A0. So this should be the 1, 2, 3, 4th pin down. Wait, what? Is it not? Wait, I might be being a little bit silly. I might be being a little bit silly. There's literally a trace going straight to the pin. Okay. I think it probably connects. Wait, it is exited by mistake. Guess what? It does connect. Did you hear that beep? I don't know. Let me turn off my noise gate for a sec. Can you hear that? Yeah. Alright. Beep boop, I am a yuk. I say beep boop, I am a yuk. Alright, nice. So that is R0/A2. R1/A1 and R2/A0. Alright. Yeah. And then all these key numbers, which I'm not even gonna bother to write down because I'm not using it for key stuff. R3, R4, R5, R6, R7, R8, R9, R10. Nice. I think that's all I need to do for this. If I really wanted to, I could make like draw these holes, but I don't think I need to. Wait, how is it posture check time again? I literally just did it. What is happening? Why is time going so quickly? Oh, also, I can't stream super late tonight. It's currently this time. So I think I might end around 11 because I have to be up early tomorrow. And this coming week's really busy. Okay. So all we need to do. Oops, shit, I just threw a pin. Okay, nice. Thank you for the pants. Oops. There we are. Sorry, I It looked like I was trying to get away from your pants. I promise I wasn't. Ah, why am I still holding that? Oh my god. Alright. We've made the patterns. It's time to make the circuit for them now. It's circuiting time. Hell yeah. Alright. This is done. So let's go to the schematic. Get rid of that. Bring this over here. Oh, wait. There's one more part we need to do before then, which is component editor. Forgot about that. Hold on. This is where you name the pins, isn't it? Forgot about that. Okay, so... No wonder I'm tired. Thanks for the stream. If you're still going, I might listen in from bed. Sure. No worries. Thank you for stopping by. Pinma. Okay. So if I go over to components... Let me reopen this. I thought the component and pattern was separate. Okay, so this... yeah, let's add a new one. Boop. King brain. The pattern is... this one. Yeah. And then we just... What's the best way to represent this, I wonder? What's the best way to represent this? Because if we're making this a schematic... Well, they're just drawing it as a bunch of diodes. I don't think this is a very intuitive way of representing it, though. I am alright, thank you, Kellen. I can't be staying up much later though, unfortunately, because look. The time... Ah, wait, it's been covered. There it is. It's late already. Also... Yeah. Gotta do a very quiet one. But yeah, Kevin, I was saying, sorry I couldn't stay for the rest of your music stream. It was very late, it was like 4 AM. Hey, look, why are we apologizing to each other? Stop it. I'm grateful that you're here. You don't need to apologize either. No problem. Okay. So maybe I could like try to draw this. Stop. Please. What? I kind of want to draw this. Because when I'm making the circuit, it's important that I know what the pins actually are, right? Well, it's not that important because as Liquid Cake said, I can fix it in software, but yeah. Where is it? Here we are. So I think I might draw it like I'll just draw it like... Sure. And I'll just sort of try to draw the individual segments. And I'll label them and label the pins as well. And that way... should make sense. Do I have enough? Is this an okay size? I'm not sure. I kind of want something up side by side. Alright. This should do. So F, so this one's a long one. This one's a long one. This one's a long one. And we've got like a diagonal one. I haven't positioned these correctly. We have one there, one there. No, this is a long one actually. Oh, this is a long one as well, right? No! And we'll have the same underneath. Well, we need these ones first. We've got half a horizontal line, half a horizontal line. And then this one needs to be wide. This is the closest to art my stream has come so far. I guess we just want all of these again. Copy, paste, and flip, however I do that. Oh, I guess rotate as well. No, that's not what I want. It's not possible to... Oh, it is. There we are. This is a very fat display, isn't it? That's you. That's adorable. It does kind of look like a face, doesn't it? Oh my god, I just realized now if I want to position text. Oh my god. It's gonna be tiny. I'll have to change the snapping. Let's add text then. What does it look like if I just try to add a... What is this? 759%. Oh, it's my zoom level, yeah. Wait, what is this size? Size 6. This is so flipping tiny. Okay, we'll make it slightly smaller. So that's A. And over here we have F. And over here we have B. Am I going to be able to fit these in? I wonder. I'm literally just like trying to draw a thing like A, F, blah, blah, blah. There's so many measurements here that you can ignore. So don't worry too much. It's a nice spiral and skips I and O. A, B, C, D, E, F, G, H, J, K, L, M, N, P. Oh yeah, true, it does, huh? It is. Yeah, they don't have any pin named I guess because it's too similar to J. And they don't have an O either. Maybe it looks too similar to A when it's printed at a small size. If you abandon logic, it looks really cool. Like math symbols. Oh no! That's scary. For me. I know Stewie's gonna be perking up there. Alright, this one is C. Let's follow the spiral around, shall we? This is C. This one will be D. I'm gonna put it up below. No, I'm gonna... What's the best way to do this? Because I'm thinking of drawing the pins on coming out like this. But then I could label the pins on the inside, I wonder. The pin side. No, I don't think I have space to do it on the inside. Sad. And you know what's also sad? It's not quite centered, but whatever, it's not centered on here either. Let's just do it the way they did it. They put one on that side for there, and on this side is the D. The E is here. It's A, B, C, D, E, F. Then we've got the tiny ones in the middle. This is where I realized I should have chosen a smaller font size, probably. This is G. This is H. By the way, Calvin, you've caught the first ever... This is my first electronic stream. I don't normally do this. G, H, J.
Yes.
Yes. G, H, J. Yeah, this is so flipping... H-tam confused me for a moment. Then I noticed the question mark, which is not printing in my chat. It's math backwards. Let me just bring up a different thing just so I have a reference. Okay. Oh, this could definitely be bigger then. Yeah, I feel like I'm squeezing this to be too... Wait. That's the kind of size you're gonna see it. Thank you, Exia. Hi, Exia. For this kind of size... I feel like this is smaller than it needs to be. Probably could be bigger. Then everything's gonna be easier to fit the text in at least. What if I just scale everything up? Can you do that? Can you like stretch stuff? I don't think you can. Oh, wait. Oh, it's... Yeah, I don't think you can stretch this entire thing. No. That's not generally what you do. You generally make it the correct size. Oh shit. Why, hello there. I heard you like ASMR that's spooky. Hi. Watch, I'm just ahead. I'm gonna float over to the middle of the screen. Whee! Oh god. Don't look at the background, you're gonna get motion sick. Joke's on me. I'm the one who gets dizzy. Report intruder? Intruder in computer room? Me?
Cheese.
No. I swear. Incredibly horrific in such a great way. No! You probably don't want the camera that close. Look, these two mix together and it makes me look like an insect. Oh, there we are, it wore off. It's fine now. It's just silly now. Wait, I have to nyan, but you did it during the spooky thing, so I'll do a spooky nyan for you. There you are. What's happening? Oh, I'm just stuck to the camera. You know how it goes. I'm back. Do the letter labels help for your circuit diagrammy thing? Maybe they are just noise in the way of routing traces. The pins will be on the outside. Yes, I want to include these for making it easier for me to know which thing I'm connecting where. Points well spent. Points well spent. Well, I'm glad. At least it wasn't cheese. I'm not having cheese thrown in my face this time, which is always a good day when that doesn't happen. So stretch that up there, this up there. Oh, maybe I need to stretch it vertically for it to be less crowded, huh? Yeah. That's better. Just bring that down. This actually looks more like the display of the correct, you know, width and height now, aspect ratio. Whee! There we are. A, B, C, D, E, F, G, H, J. And then we've got K on the middle there. K. Oh, but yeah, I should probably explain what I'm actually doing, Kelvin. It's... Hold on. I have some of these little displays! And I want to make a little circuit board that I can put them onto and control without needing to connect 32 wires per pair of these. And I also have this to control them. I'm going to need to use 2 of these because each one of these can control 8 characters. And there are going to be 16 in total. And yeah, I wanted to make a thing. An old style. This one's messy, I don't like this K placement. Like a, you know, kind of nostalgic, what do you call it? A nostalgic looking display thing. And then, because I'm a VTuber, I'll probably have to remake it in Unity, but so it can actually be seen. Alright, then we need L. I don't like how this L looks, but so they did it. Then we need M. Ugh. Eesh. This one's wide, huh? Damn. Wait, this is meant to be the middle one, right? The middle one's M. Okay, I'll put it over there then. a way I could like shift scroll wheel? No, I thought there was something I could do to change the scaling. Can't remember it though. Can't change font? I can. I mean, this is a vector font, but I can. I mean, you could say that most fonts are vector fonts, but it's not a true type font. LMN. But you can make it true type, but I don't want to. I have already made it quite small. This is already really small. We're at a huge scale. We're at over 1000% scale right now. Okay, and only one letter left, which is P. So we could put that right next to K. Or we could put it on the other side. I think we'll put it on the other side. Wingdings, no. Wingmudding. I'm gonna move that one up a bit. Then we can move this one up a bit, I guess. Or not. No, it is not. I reckon this will do. Yeah, this is fine. I think this is fine. Now I gotta do it again on the other side. But we can just copy and paste it. Thank God. Boop boop. Sure. Sure, we centered this as well. Not many people are barking about having it not centered. Probably just me, really, but. Okay, then how does this work again? Digit 20. Okay, so it's like mirrored. Dig 1, dig 2, 25. So this ground pin here is 23, 24, 25. Is this middle pin here? And pin 30 is 32, 31, 30. This middle pin there. So they're basically just mirrored by the look of it. Oh, right, decimal points. I forgot about decimal points. Hold on. Let's make a little circle down there, I guess. That'll do. Oh, actually, it's actually outside. There we are. And then I might as well label that as well. BP1. It's pretty wide. But whatever. Eh. This is not the neatest thing I've ever done in my life. But you know what is? Well, no, that's not true, but you know how to make it less messy? There we are. Just give yourself a bit more room, you. Ta-da! Problem solved! Yay! Okay. Sure, that'll do. That's centered. I guess so. The 2 is wider here, so. Okay. Let's add the pins. Oh my god, how is it this time again already? Thank you though. Thank you, center. Wait. Ah! There we are. I'll lean forward so that doesn't touch me. Wait, hold on. There we go, one of them touched my hand. Did you see my hand wiggle? Thank you very much for the bits, Sabi. Hydration of the stream? Yeah, it probably will be. If I end at a proper time, it will be. Hopefully. I could number all of these A1, B1, C1, D1, and all these A2, B2, C2, D2, but let's not. Also, all of these points can, like, I don't have to expose them. Like, the order here, 18, 19, 14, 15, 16, 32, 17, 31, that, I could expose them like that just along the top if I really wanted to. And then, you know, they could just be connected in a straightforward way. Yeah, you know what? Let me do that. I'm gonna do that. It's exactly what I'm gonna do. This is why we have the separation of schematic and, I mean component and, what's the word? Pattern. Thank you for the pats. What? You interrupted a Sento's headpats? Did you? Oh. Wait, did it? Wouldn't it have continued? But don't worry. I can... I mean, what, was it bad? Also, wait, pin placement setup. Can you... Oh, you can do a row of pins, okay. So if I want 14 of them... I'd need it to be wider. Or just have them close. Wait, let me have a look. Oh, that is standard width actually, isn't it? I'll just make this whole thing a bit wider then. Wait, why can't I get rid of them? The? What the is it? Does undo not work? Is there no undo? There should be undo. That's weird. Okay, let's make this wider. 1, 2, 3, 4. 1, 2, 3, 4. Is that wide enough now? Must start at 1. Not quite. Not quite. Almost. Undo works now. 1, 2. 1, 2. More pads that exo face though. It's a goodie, man. Nice. Perfect. And they can be numbered not in a straightforward way, unfortunately. This is 18. Wait, why is it not? Wait, do I really need to change both? Oh my god, do I really need to change both? That's stupid. 19... Oh, actually, you know what? Number 18, but name, I can name A. Oh my god, sorry. That was a loud crack. Where does it show them? A... Okay, you know what? Let's just... Hold on. Let's turn it on for all of them. And I'll position where the names appear. Wait, can you not do that? Would you do it through the... I think I know where you do it. Come on. Oh my god. Struggling to right click here. I guess the names appear somewhere else. I mean, I guess where you set the names, the option for that appears somewhere else. Yeah. I guess it's only on the schematic where you can choose... Hold on, let me just go to the schematic for a sec. Thanks, Uni! We've made the patterns, like there's the layouts as things appear on the board for this and this, which are the two things I need. And now I'm starting to make the so-called component for them, which is actually a step that I forgot that I have to do. Which is like more... So it's like this part? Hold on, it's loading. Oh, it's already up, hold on. This part is like the graphical part, if you like, the physical part that's actually gonna affect what gets drawn and where the holes get drilled on the board and stuff. And this part is like the more, how do I explain it, the more logical part or theoretical part. Basically, you can make something in here that doesn't really match how it is physically. It's just for drawing a diagram so that you can like connect all the lines together so that it knows what goes where. And then the really nice thing is that when you come to make the actual board, because you've made a schematic, it'll know what in real life needs to be connected to what other bits in real life. This is like, I guess you could call it, it's like sort of, I don't know, the more abstract part? I don't flipping know. I don't know. Oh my god, I just changed everything. This is a tedious part where I have to name everything in this weird order. C, D, E, F, G, H. Oh, I'm gonna need an extra pin, aren't I? The common one. Yeah, this one. Forgot about this extra pin sitting on the top. Guess I could put them out on the sides. Yeah, I'll put them out on the side. So the top row is going to be for the left digit, and the bottom row is going to be for the right digit. I'm calling them digits, but they don't have to be digits. So A, B, C, D, E, F, G, H, J. There is no I. K. But yeah, I hope you're doing alright, Uni. L. I've had to go into ASMR mode because it's become late. Oh, it's actually very late. E. Wait a minute. I still need another pin. I don't have one for the decimal point. Wait a minute. Alright, screw it. I'll just add it by myself. Like a pleb. 1, 2, 3, 4. Oh god, what just happened? Thank you, Heaney. 1. Oh my god. 1, 2. Boop, boop. Control C, Control V. Boop. Wait. Oh. There we are. And this is DP1 decimal point 1. Now let's number them all correctly. So it's 18, 19, 14, 15. I really want to not mess this up. 16. Wait, is there a shortcut for... Probably not. Wait, maybe there's a shortcut. Let's try. Oh, this might be faster. 16. 32. 17. That's not a thing I can easily alt to, but whatever. Why is the word schematic so against peanut butter? Wait, what? PB? I'm doing well. I hope you're doing well too, Kian, everyone in chat. I am okay. Thank you. 17, 31, 29. K is 28. 4L is 4. M is 3. N is 2. Oh, that is nice. I can just scroll with the scroll wheel and it moves to the next one. Okay, nice. This is actually faster. 4, 3, 2, 1, 5. Okay. Now, copy and paste. And... oh no, flip, I guess. Flip. Boop. Oh, hang on a second. Have I dragged something I shouldn't have dragged? Wait, what is this? Oh, I accidentally copied these. Oops. Okay, flip. Boom. Okay. So going across the bottom, they're all labeled correctly. Now I just need to change the numbers. Where was it? Pin manager. Oh, it's confusing. They've got the... Wait, am I changing the correct one? No. I think these are the ones. Okay. So we want 21, 22. Oh my god, I can just press enter. Holy crap, this is so much faster. 11, 12, 13, 27, 20, 26, 24, 23, 9, 8, 7, 6, 10. Holy crap. I wish I'd known that I could do that before. Okay, nice. Okay, now I just need the final 2 pins for the commons on the side. I'll put them. Maximum laziness using this. I just want to flip. I don't think it's a keyboard shotgun. Whee! Thank you for that. Hold on. I think I've been silly. I have been silly. These squares on the end are where it connects to the other things outside in the circuit. I've got all these pins upside down. That's why the letters are on the wrong side.
Holy crap! Oh my. Welcome. I flipped the wrong thing again, goddammit. It's evil ASMR. I hope you like it. 1, 2. Why do you be patting the evil cat? Everyone knows cats are evil. I'm kidding. Okay, one second. Wait, you can't see my hand. How am I gonna pat you? You can't see my hands. As I get my hand close to my face, it messes up my tracking. Okay, there you are, there you are.
Pat, pat. There you go. Pats for the Kinami. I'm sorry, I couldn't pat you while you were stuck to my face. Best kind of ASMR. Okay. Okay. You as well, F-bomb. One sec. Oh god, sorry. I just poked your eye out. One sec. Pat, pat. There you go. Sorry about that. Hope you can replace your eye. Why are you dragging these around? I'm not trying to. Stay down. Thank you. Okay, now these need to be flipped. Boop. Okay, nice. That looks a lot better. And these need to be flipped. Boop. Okie dokie. Hope you can replace your eye. Yeah, it's a bit Baldur's Gate. Wait, is that spoiler? Never mind. You didn't hear it from me. I said nothing. Okay. This is kind of messy still, isn't it? But whatever. It's also not centered anymore. I guess I could stretch this up a bit. Oh, it only needs to be one higher, right? Yeah, it needs to be that high, actually. 2 higher. Alright, now it's all centered. And these final 2 pins are 25 5 for the top row, which is let's call it com 1, I guess. Common 1, and we'll show the name. Oh yeah, right, these are the wrong way around as well. Flip. And then this one is, wait, common 1 is 30, sorry. Common 1 is 30. Oh no. Okay, I will stop. 25. This is com 2. Com sa. Wait, I did the wrong thing. The number is 25, the name is com 2. And we'll show the name, which I keep flipping forgetting. Alright, there we are. Maybe I'll move these up a bit. Why do these two keep getting left behind or joining in when they shouldn't? I know they're not centered anymore, but whatever. Okay, so that I will probably leave it there for now, but that just leaves making this component, which should be pretty easy. It won't need any like fancy graphic stuff in the middle like this. God, this looks a mess, doesn't it, when I zoom out? Oh my goodness. It just needs to be a rectangle with some pins on the sides like that. And then I can connect them all together on the schematic. And then I can lay it all out on the actual board. That'll have to be done next time though. Alright. I think I'll have to call it there. Sorry, this is something that I would have liked to have continued. Wait, there we are. Sorry, that's too high up. This is something I would have liked to have continued on into the night, but I'm afraid this all of the coming week is... There's a lot to do. So, I honestly don't know if I'll even be able to stream that much next week. I'll try. It might end up having to be like in the evening because during work hours, like business. Oh, where's my hand going up there? During the business hours, I'll have to actually be doing stuff because for some reason, some government places don't like to be open in the middle of the night for some reason. So I gotta do that during the daytime. Alright. Anyway, I have a spare eye for you. Wait, what? An eye? I'm actually surprised how close I was able to get. Life sometimes gets in the way. It does. And you know what also happens? Everything always happens at once. It's never like an easy thing. Anyway, no, you're welcome, Yini. And yeah, you're welcome, Kinami. Everyone's welcome. Thank you for being here. No, don't poke the eye. No, I won't do that. It also wasn't aligned. Alright. Let's see who I can pass you on to. And yeah, thank you all very much for being here. Sorry. I need to give proper thanks. I appreciate it. Very much. But I do have to be disappearing now. The derpy one, I needed to be, oh my god, it looked like the derpy floating uke was doing like this, because the hand was up. It was two different ones. Also, thank you for the hydration and posture check. Turns out they were not quite the last ones on the stream. Ah, it's loud. Thank you. Oh my jeez. I swear to god, the whispered cheese still gets me. Especially when I'm having to be quiet. Thank you for the pats, Uni, and the posture check as well, right? Posture check and hydration is into. Okay. So long, and thanks for all the cheese. No, you, but not actually thank you for the cheese. Because you're the one who gave it. Ah, get off my eye. Yeah, this is like sensual. Jeez. Right, who can I pass you on to? Thank you, Stewie. Who we got? Oh, Paul the Alphanet's on. I haven't read into her in a while. Exo's on. Remy is on. I haven't read her in ages. Tough choices. What would be the least suddenly really loud? Armored Core is probably going to be pretty loud. Tetris is probably going to be pretty hype. It's probably going to be... Oh, wait. Huh, there is actually ethics. Ethics is streaming art and apparently even muted, so this would be a calm one to raid into, I guess. Grooming stream? What, just constantly patting me? Yes, grooming can be like a cute thing or a less cute thing, huh? Thank you, F4. But yeah, this is gonna have to be a raid and run. I'm not gonna just stick around. I'm curious about what Setalex is doing. Something with Unity. And my tab's just crashed. It's reloaded. Oh my god, it's not even reloading. You know, like monkeys and stuff. Yeah, that kind of grooming. Yeah. So when I have my hand like this, it's because I'm touching my mic. It's invisible. But yeah. Oh, this one literally says warning jump scares with exclamation mark distract and bits. So I probably shouldn't pass you on to that. I thought you play with your hair. I do a little bit, but I also just play with this a lot. Sorry, F4, sorry. But Setalex is so nice. Why is it so hard to find someone who's raiding? What if I just search for electronics? Probably no one is, right? Linted is the only person I know who does electronic stuff. And he's not streaming. Oh, he's any VTuber I know who does, anyway. There are actually only 4 channels right now doing it. Someone is 3D printing. Someone is doing some actual wiring of like something for like a remote control plane by the look of it. One of them is fixing stuff. A PS4 apparently. That's interesting. And one was me. Mike is lucky. Who's Mike? Is that the name of a channel? Or is this some pun? I never know. I never remember what I said, so I can't remember it well enough. Thank you for the pats. Sorry, crap. Alright, I am gonna pass you on to drumroll. Drumroll? The drumroll is me waiting for Twitch to load. Sorry, you don't have to provide it. It's just me trying to provide. Me trying to fill in the blank while Twitch loads, and everything's so slow when I'm streaming. Still waiting for Enlin to remake PC Face. There you go, thank you, Hitchhiker. I'm doing a drum roll on my keyboard. That's as much as I can do without disturbing people. I don't know who to raid. Who's it gonna be? You know, I'm passing on to ethics. I mentioned ethics before. I'm passing you on to ethics. Boop. We're going here. Ta-da! Silently working on comms. And then there might be Among Us later. That might be less calm. But yeah, ethics is an artist. Currently doing some pixel art stuff. Commissions, apparently. So yeah, that's gonna be all. But yeah, bye! I'm finally going now. Sorry for making you all repeat. But I'll repeat as well. Thank you all for being here. I'll stream when I can this coming week. It's a bit... you know how it is sometimes. But yeah, bye for now. I kind of definitely want to finish off this electronics thing. I reckon we can get it finished on the next stream. Should be pretty easy. We did all like the complicated, intricate, like trying to measure everything precisely stuff that takes ages this time, so next time it should be the more just like fun actually connecting the dots and routing the traces. Yeah. That's all for now. Bye bye bye. Thanks for being here, everyone. I'm gonna disappear. Ah! Wait.